Hello everybody, Zachary Fruhling, aka Cozy Azeroth here. I'm going to be getting started working on a new retro game that I'm going to be programming with the help of my friend Dylan Metzing, who's going to join me here momentarily, in TI Extended Basic for the Texas Instruments TI-99 4A home computer. We literally have nothing programmed. We're going to start from scratch. It's not going to be a one-day project. This is a many day project probably. Let me get into Discord real quick since he's going to be joining me in Discord. So half a second. And I got to share my screen real quick here in Discord so Dylan can see what I'm doing. Let's see. Share screen. Screen one. Okay. There we go. So Dylan should be joining me in a minute. We are going to be working on a game that is hitherto unnamed. I have in mind this weird little retro game where, kind of like in the style of the old Adventure cartridge for the Atari 2600 and or something from Gertrude's Secrets, where you're a little square, but that square is Socrates wandering around a map of ancient Athens. And like Socrates, encounters interlocutors and people to talk with, people to debate with, kind of like a small, very self-contained, but semi-open world adventure game that's largely dialogue driven. It's not really a game, more like a learning experience, more like a little exploration game. I guess it's a game. Games don't have to have winners, right? I guess Socrates is the loser. So I have a design document I've been working on. I'll read you the description. Yeah, it sounds big. We're going to make it really small, though. It's not going to be very big. It's going to be very small. Hey, Odd, how you doing? It's going to be, we're going to have, the big Platonic dialogues, like the Euthyphro, that takes, yeah, exactly, Socrates' Chinese child. It could be the name. That takes place out in front of a courthouse or something to that effect. We've got the symposium that takes place at a dinner party at someone's house. So each room of the map is going to correspond, room and an outdoor room, each area of the map, screen of the map is going to correspond to one of these geographic areas / settings from the major Platonic dialogues. That I don't think is going to be too hard. The hard part is going to be coming up with the interface for a little bit of branching dialogue and possibly writing the dialogue itself, taking the philosophical dialogue from content from those dialogues, compressing them down into a very small branching dialogue. I think it's doable. I think in Extended Basic there'll be enough memory to be able to do that if I keep it really small. Of course, abstracting the map is easy. We're going to have some very simple, very minimalist graphics. We're going super abstract and super minimalist for this game. In preparation, I have the TI Extended Basic manual up here. This is just a version that I found on archive.org. I don't have a physical manual here. Oh, bloody hell, let's reload that. There we go. Don't need all that highlighting. It's been a while since I've written anything in Extended Basic on my own, so I thought I would pull up this manual, just give it a little once over, and then we're going to dive in. Dylan said he's going to be joining me on audio, but he is on his way to the hardware store, so... Ooh, 1 second here. Oh, got a message to respond to. Give me a second. That's weird. Sorry about that. I just had a message to respond to. Okay. Alrighty. So yeah, it's been a while since I've done Extended Basic. Defining characters, no big deal. But I can never remember, let's find it here. This should be under yeah, here we go. How many characters we have across the screen? It's 32 across, 24 down. Starts at 1. Okay, piece of cake. And then when we're using sprites, it's not done by character, it's done by pixel, right? So let's go look at call sprite. Let's see, where is it? Just got to remind myself here. Okay. Okay, where is sprite listed here? It must be under S for sprite. Sprite subprogram. Here we go. Okay. Okay, row and column velocity. I got to remind myself all the details here. Okay, dot row can be from 1 to 192. Dot column can be from 1 to 256. Okay. So yeah, we're just going to dive in. Dylan will be joining me in a minute, he said, in Discord. So let's get into Extended Basic. And I think before I do anything, let's just give this an old call clear. And we're going to save this as Socrates. And we're going to save it as Socrates work in progress. We always have an official version and a backup version. Work in progress version. All right. Well, we know we're going to need some things. So I suggest, just to make this easy, I think what I'll do is have the starting screen be just we'll kind of arbitrarily, we'll call that map X, map Y, 0, 0. You know, that way we can, you know, it doesn't really matter. It's just arbitrary. We can go left and that's negative. We can go right and that's positive. So let's just, and then I don't know how many, what the map's going to look like yet. So let's just come up with a schema that's going to work no matter what we do. So 20, let's call this map X equals 0, 30. Actually, I guess I should do this. You know, it's funny because I'm not really, let's list this out. I'm not really used to using Extended Basic because I didn't have that when I was growing up. So I have to kind of remind myself some of these things I can do on a single line. Map Y equals 0. Okay. And 30. Let's start defining our character. We know we're going to have, we're going to be highly abstract. So in the style of an Atari 2600 game, Socrates is going to be just a solid square. So 16 Fs is the hexadecimal. So let's call this Socrates string equals 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay. Socrates, tiny child. Child of Socrates. No, I don't know what I'm going to name it. You know, Socrates' Adventure doesn't sound quite right. Socrates' World. Socrates' World isn't too bad. Let's get that on the screen. So again, because I've used, you've seen Odd that I've been typing in old TI basic, extended basic programs for some time, but you know, it's been a long time since I've written one myself. So constantly just kind of checking my work here. Okay. So how does this work? What's the format here? So sprite number, character value. Oh, you have to define the character first? Is that how you do it? Okay. The master is making. I'm working on it. It's always slow going when you start a new project, right? Because you don't want to go down a path that's going to lead you. You don't want to go down the primrose path, right? You want to go down a good path. 1 second here. Oh, Dylan wants me to send him a link real quick here. Let's see. Copy link. Okay.
Hello.
Hey there.
Oh. Hello.
Hello.
Can you hear me?
Yes, I can you hear me? I hear you
I
okay.
have some sort of permissions turned off. Oh, hello?
Hello?
Did that do it?
Can you hear
Heck,
me?
I don't hear anything.
Can't hear me? I don't think I'm muted. Nope, I'm
I'm here.
might have to just check your audio settings. You can't hear me.
Hello? I don't know what's happening.
I'm muted? Really? You can't hear me at all? That's weird.
Hello? Heck, is that?
Okay, hold on here.
I'm getting out of the door, and then I'll try to maybe just give you a call. I'm not sure where to set the, like, allow it to let me hear. I don't know if there's some sort of privacy thing stopping it or what's happening.
Okay, I'm not muted. So if I'm are you messing with me, Odd? How if I'm muted, how come you can respond to me?
All the volume stuff is turned all the way up. I don't see
Hello,
anything
hello?
that should be stopping me. What the heck?
You're funny, Odd.
If you can hear me, can you put it in the little chat in the lobby that you can hear me?
Yeah. 1 second, let me figure out how to do
Maybe I'll
that.
just give you a call.
Hold on, I'll just message you, Dylan.
Oh yeah, you are typing. Oh crap, you can't hear me. What the heck? Why can't
Oh, yeah, you should be able to hear him.
Weird. Okay, well, I will maybe stop talking. I assume you're talking too.
I'm talking right now.
Watch screen.
Strange, strange. Technical difficulties. It's like starting any new project, you know?
Hello?
Hello? Can you hear me? I'm not muted.
Yeah, I don't see anything that should be stopping me. I've like all the audio things are set to on, the volume's all the way up, my volume's on. It's set to come out of my phone. I have no idea why it's weird. You will make sure my voice is working. I just played one of your last videos you posted and that worked. Why I can't hear you right now?
You could just call me on the phone, I guess. I can put it on speakerphone. It'll probably come through.
Settings are there. I'm just like looking for more settings options. Maybe somehow I have you muted somehow. Can't find anything that
Yeah,
says
his audio is
anything
coming
else.
through, but he doesn't seem to be able to hear me. Weird, weird.
Yeah, the deafen is off. Showing that I have voice sensitive. Oh well, you can hear me. I just can't hear you. Volumes are 100%. Yeah, maybe I'll just try giving you a call. Can we call? Well, I guess I'm probably not going to be looking down too much anyways, because I'm going to be driving. I can do most of it just from hearing what you're talking about, but right now I can't hear you for some reason.
Yeah, it's okay. I'm gonna. You can't hear me. I mean, you're talking as if you can hear me. Let me message you here. Doo-doo-doo. Hello.
Hello, is that working?
Yeah, I think so. I think that'll work.
Okay, am I messing with the Discord at all?
Oh no, I just signed out of the Discord.
Okay, perfect. I was like,
Yeah, well, it's a shame because you won't be able to see what I'm doing, but you're driving anyway, so it's all good.
Yeah. Perfect. Okay, yeah, I don't know what the heck that was about. I was like, why can I not hear anything at all?
Yeah, yeah. Well, we're back from Vegas and ready to start making games again. So I was just starting work on the Socrates game. Oh, good. You can. Someone's watching on Discord on Twitch, and they can hear you just fine through coming through my microphone. So that's perfect. You there, Dylan? Now I don't hear you. Hello, hello.
Can you hear me now?
Yes, I hear you.
Okay. I put you through my car because kind of hard to hear you without it being through my call, but I guess that's
Yeah, that's okay.
Be able to talk.
I was just he's here now. I rather than coming through Discord, I've got him just literally on the phone on speakerphone next to me, so the speakerphone is being picked up by the my webcam mic. So yeah, I'm just starting to work on the Socrates game. I've got 3 lines of code in, so.
Cool. Yeah, I saw just a little bit there before I called you. It does look way more reminiscent of Pico 8.
Yeah, it's funny because in a way it's more retro than Pico 8 because Pico 8 is designed, it's modern, but it's designed to look retro, and yet in some ways there are fewer constraints than on Pico 8. In some ways there are more. They're just different constraints,
Yeah.
I think there's we'll probably find we're not going to run up against the token limit, but we're going to run into, it's not going to be as it doesn't refresh 30 times a second like Pico 8 did.
Yeah.
Or 60 times a second, whatever it did, 30 times a second.
Whole new environment.
Yeah, definitely. So I know I literally just all I've done so far is I've cleared the screen. I've got an XY coordinate for the map. I figure what I'll do is each screen will have a coordinate location. So we'll start the start screen will be 0, 0. Then if we go up, we'll just increment or decrement the y variable by 1. If we go left to right, we'll increment or decrement the x variable by 1, and that's how we'll know what screen we're on.
Okay.
And I was in the process of defining the character of Socrates. So this old system has 32 characters across horizontally and 24 characters vertically. Each of those characters can be an 8x8 pixel or 8x8, what we're calling a sprite. An 8x8 character. So each character is 8x8, and you can have 32 across and 24 of those down. That's what we have to work with. So I was just defining the character of Socrates, and each character is defined with a hexadecimal code. So you can take that 8x8 grid, and there's a way of breaking it down into a hexadecimal code, and that's how you tell the computer which of those 8x8 pixels to turn on or off.
Okay.
So, and since Socrates is just going to be a little 8x8 square, it's just 16 Fs that's the hexadecimal code for that character. And that's as far as I've got. I was just defining the hexadecimal code for Socrates. So what I was hoping to do today is just be able to get him on the screen and make him move up, down, left, right when you press the key or use the sort of virtual joystick.
Okay, yeah, let's do that.
So I have to remind myself how to do that. So I was literally just looking up the program for getting a sprite on the screen. So I need to define a character. It has to be a character number. Each character has a number, and the characters are grouped together in terms of groups, and then each group, you can control the color of each group separately. So I'm going to just pick a character, let's call it 96. Again, some of these choices are going to sound totally arbitrary to you since you're not familiar with this, but I am doing it for a reason. So let's see, call char, that's how you define a character, and I think it's 96, and we're going to do it, I called it Socrates. For the string variables, you know what a string is, right, as opposed to a numeric variable, a string variable has a special way of being named in this system. You have to use a little $sign after the variable name, so Socrates $sign is what I'm calling the hexadecimal code for Socrates. So Socrates string or Socrates $sign. And let's see if we can get Socrates on the screen here. Call sprite. How are you doing, by the way? It's been a few days.
I'm doing good. Yeah, Max and I got very tunnel visioned on music.
Oh, yeah.
Max has been working now. He got a job as a substitute teacher.
Mm-hmm.
So he's been going to work, and while he's been working, I've been staying at his house and working on music and having like some solo time to kind of get into it, which has been really fun and new for me. I haven't ever had time by myself to work on music before.
Yeah.
My first time having that like solitude with it, which has been really good. But yeah, I got pretty caught up in it. I didn't.
That's okay.
I'm down there for like 5 or 6 days at a time now.
which is different. I've never stayed down there that long before, but the last few weeks I've done that just because he's working all week. But then we're like wanting to do music over the weekend.
Sure.
But yeah, it's been good. Definitely dove pretty headfirst into music and kind of got lost.
That's okay. So you didn't have a chance to play with any of the sprite makers for our other game at all, then, right?
Nope, not so far.
That's okay. I mean, I'm happy to start work on this one. This is I at least can get started on this one, whether or not we've done anything else. You know,
that's
so
what I was thinking.
So it's all good.
I need to kind of test through some other ones because I wasn't sure about that one. And since I'm going to have to buy it probably to even send you anything that I make in it.
Yeah, yeah.
I need to really spend a couple hours probably and just try out like 4 of them or something, like 3 or 4 different ones.
Yeah, that works.
And then I'll probably pick one and buy it.
Sounds like a plan. So this line I'm typing in now, so the TI-99 4A uses what it calls call statements in the sense of calling a subroutine. So one of the subroutines or subprograms is the sprite subprogram. So I've typed call sprite, and I've got a number of parameters I have to feed in: the sprite number, the character value, the sprite color, the dot row and dot column where it appears on the screen, and then any velocity that it has, which is going to be 0, of course. So right now, I just want to get this on the screen. So we're calling it sprite number 1, character number 96, color, let's just make it, I don't know, gray for now, I guess. Dot row, dot column, let's just do 100 by 100. And velocity 0, 0. I think that's optional. So I think if we do this, if we run the program, oh, okay, yeah, it doesn't. We need to. Let's just. I need to list out the program. I forgot it ends the program right there. So let's just, in the interest of seeing our work here, 60 go to 60. That should keep it on the screen for now. Okay, yeah, there we go. We got a character on the screen. Boom, Socrates is on the screen. It doesn't do anything yet, but it's on the screen.
What does it look like?
Yeah, here, I'll take a. I don't have a border. I don't have anything. I'll take a little picture.
Oh, that was quick.
Yeah, and that's the thing. It's actually really quick to get stuff to happen on the screen in these old systems. That's their advantage compared to even modern retro programming methods. Getting simple stuff to happen on the screen is remarkably simple in these old systems. So I'll send you a picture here of just the one little. Yeah, there you go. That's a picture of my computer monitor. You can see a dot in the screen, not exactly in the middle, but in the middle-ish.
Cool. Still loading, but excited. Maybe it's not loading because we're on the phone.
Yeah, should be okay. Give me 1 second. I'm just sure I have one more message I have to respond to here real quick. Sorry for we have someone watching on Twitch who's watched many of my TI streams. His stream name is Odd One Man. He just wants me to call him Odd, which I love.
Oh, there we go. Oh, cool. Oh, I like that color.
Yeah, that's the kind of default screen color in the TI. There's only 16 colors in the system, so.
Perfect. I like that one a lot.
Yeah, it's kind of. I was sort of thinking gray on blue like that is not a bad. We'll play with some combinations, see what looks good.
Yeah.
Cool.
Oh, hi, Socrates.
Yeah. Hold on 1 sec.
Uh-huh.
My ex-wife messaged me. She's found something in the garage that might be mine, and at her old house. And then I got to worry about this car. Her car is still in my name, so just messing around with stuff. So I just got to respond to her real quick. Then I'll be back and give you my full attention. Okay. So yeah, so right now we just have a dot on the screen, but we want that dot to do something. We want it to move, right?
That dot. Move for that dot.
Yeah, so I think what I'm going to do, let's list out the program here. I wish you could watch this because it's here. I'll send you a picture of what I have so far. I know this is kind of weird since we're supposed to be doing this together, but I'll take a screenshot of what I have so far. You can see. So we have 6 lines of code. So in BASIC, Odd, thank you. I found a good extended BASIC book for me. Yes, please, absolutely send me a link to it. That would be very helpful. So we have 6 lines of code. Unlike when we were working in Peak 08, BASIC has line numbers, and the code is executed in sequence. And so if you want to branch to a different part of the code, you use a go to statement that tells you go to a different line number, and then you return back to the line number where you're at. So it's a lot of bouncing around, which is a little confusing when you're writing something complicated. Is it totally distracting to look at that while you're driving? I probably shouldn't distract you while you're driving.
It's okay, I can always pull over. I'm on the dirt road still. Yeah, there's a beautiful lookout coming up that I'm going to pull over at for a second and look at it.
Yeah. So now I want to make the sprite move around. So I need to... I'm going to use, I think I'm going to use because I'm on the emulator, I can use the joystick control for this. There's a program for controlling the joystick called Joist, I think it's called.
Joystick.
Yes, here it is, joystick. Okay. So I think what I need to do, let's start, I'm going to get rid of line 60. And now we need to start using subroutines. Otherwise, we're going to end up with a rat's nest from the very, very beginning. So I got to remind myself how this works here. We're gonna use a subroutine, but I got to remember how to do that. There's a command called go sub, I think, which sends you to a subroutine. Yeah, here it is, go sub. Okay. Okay, line number. Oh yeah, okay, so it sends you to a different line number, then when you hit a return statement, it sends you back to where you were. So I think I'm just going to make this kind of arbitrarily large for now. We can always renumber stuff. Part of what's tedious about this, and I think what I might do, I might actually switch to a modern code editor for writing it, because you can paste it into the emulator here. But not yet. We'll just plug along here for a little bit and see how it goes. I want to get something happening cool on the screen just to show we're working on stuff, you know. So let's say 60 go sub. Actually, you know what I'm going to do? I'm going to make this 100. Go sub 10,000. Then line 10,000. With a remark. This will be player movement. By convention, you tend to do line numbers in increments of 10. So that way, in case you want to insert or something, you at least have 10 lines of code you can insert between lines. But it's not as easy to add stuff as it is in modern environments.
Cool.
So
it's so fun looking at different worlds.
Yeah, that's the thing. Each environment is a totally different world. There's a lot that's similar. You have variables, you got if-then statements, you got loops, but you know each system has its own constraints you got to get used to and its own syntax. You know.
Yeah, Yeah.
It's a little bit of a gestalt shift. Oh yeah, and you can, there's a command to renumber, which will automatically renumber all your code to make the numbers make more sense. So, yeah, that's right. We can do that after we get a little progress going here. So go sub. Now I want to detect the movement. So let me find the joystick subroutine here. And I think on the emulator you can use the arrow keys as if they're the joysticks. So I'm going to assume that's true. So call joist, key unit. Okay, I got to remember the syntax here. Key unit X. Oh wait, key unit X return Y. What is the key unit? Numeric expression with value 1 through 4. Values 1 and 2 are joysticks 1 and 2. Oh, values 3 and 4 are reserved for possible use. Okay, so joystick 1, and then return X, return Y. Okay. So we want to detect the joystick motion, and then we want to use a call motion statement to move the sprite. Very much like what we see here, I think. Sorry, I'm looking at an example on the screen in the manual here. Yeah, so joystick 1, okay, call joist. It's a weird joyst, and we're using joystick 1, and we're going to call that. I don't want to just use X and Y. Let's see. Joist X and joist Y. I'm a big fan of descriptive variables, as you know. Okay, but because we're in a subroutine, see, this is what's so weird. I always gotta remember how this works. So right now, all we're doing is checking for player movement. So we're gonna check the joystick, move the player, exit the subroutine, and then we're gonna have a loop that will go back to the very beginning because we're gonna add a bunch of other stuff into the main game loop, like any dialogue or any whatever. Changing the screens or encountering other players, none of which we know about yet. So this is just one of the things we're going to do every time the game loops. So for right now, we just want to do this once, move the player, and then exit the subroutine, I believe. So 1020, call motion. And we're going to move sprite number 1. And let's see what's happening here. Why is this? Oh, I see. Because the yeah. It's so weird because the joystick controls, if you move down, the value of the joystick status is negative, but that means you have to add a positive value to move downward on the screen because it's counting from the top left of the screen. So we have negative joist Y, comma, X. Yes. Joist X. I think that's right. And we'll get out of the subroutine now. Let me just double check that I'm doing that right. You know, part of what's fun is like, you know, just diving in. You just learn it as you go. I've done some of this before, but it's been a lot of years on this. So, yeah, if it doesn't work right, you just figure out where you went wrong. Okay, so now, So at line 100, we loop back to, at line 10,030, we loop back to line, after line 100. So we can do, let's just call it line 500, be the end of our main game loop. Go to, 100. Let's see how we did here. Oh yeah, look, it's moving. Check it out. I got it moving. You can't really, it's pretty slow, but you, so I'll probably want to speed this up a little bit, but yeah, or maybe it's fun to walk around slow. Yeah, I'm literally just like up, down, left, right, diagonally. We got Socrates moving around on the screen.
Nice. Let's go.
Yeah, here, I'll just do proof of concept. I'll move the sprite down to a different spot on the screen. This is not done by programming. This is just done by me controlling it. So here's Socrates in a different part of the screen. It's a little slow. Might want to speed it up a little bit. Maybe not. We'll see. There you go. There's Socrates in a different part of the screen. And I'll list out the program so far. And you can see what we've got so far.
For some reason the pictures haven't been loading. I got the first one, but the second one never loaded in, and I haven't got the third one yet either.
Oh, weird. It says delivered, so I don't know what's up with that.
Yeah, hopefully they'll probably turn up at some point, I guess. At least I close the conversation and come back in. Yeah.
All right, I sent you a picture of the program so far.
Cool.
Pretty cool, actually. You know, it works really well, actually. It's actually kind of amazing how smooth it is. It's smoother than I thought it would be.
I love it.
I mean, it's jerky. It's still one pixel at a time, so it's not like smooth because the system is so pixelated. But yeah, it's actually pretty responsive. You know, you change directions and boom, you're changing directions.
I wonder if we can add an animation where, like, as the box moves, like a trail of it stays there. Like there's a little trail that's like fades out as you move further.
Maybe.
So you can like kind of be a trail of where you've been.
Yeah, probably. We probably just have to add a second sprite, like a trailing sprite or two. One of the limitations built into this, you can't have more than 4 sprites on the same row or at the same spot horizontally.
Oh, okay.
So we have hard limitations in terms of what we can put on the screen.
Okay, cool. Yeah, 2 would probably be good because then you'd have 3 squares total.
Yeah.
And if like.
But then if we're gonna have sprites for other players or whatever, that's gonna or the other character, the non-playing characters they're going to be interacting with, or any of the. So not every graphic has to be a sprite. There are other ways of putting things on the screen. But so anything in the last game we were calling a sprite. In the TI, there's a difference between characters put on the screen and sprites put on the screen. Sprites have autonomous motion that you can set their position and set a velocity, and they will just run while other things are happening. As opposed to, like, if I say print something on the screen, there'll be text that prints on the screen, or I can print custom characters to the screen, custom graphics characters. They don't have to be sprites to be put on the screen. So all of our background graphics, anything we're going to do, those aren't going to be done with technically sprites. They're just going to be done with plain old ordinary character graphics. Sprites are going to be like our player and Socrates, and then probably the interlocutors, and those will be sprites because we want to control their movement a little bit. But everything else can be done just with plain old graphics on the screen that aren't technically sprites.
Okay.
Yeah, so on the TI, sprite means... In fact, I do think that TI was actually the first system to use the term sprite. If memory serves. Yeah. But so sprites are things that can be moved autonomously. Like, so right now I'm controlling it with the keyboard, but I can set it to just move at a certain velocity, and it'll just literally go off the screen and then fly on the other, back onto the screen at the other edge of the screen, and it'll happen no matter what other code I have running. It'll just keep happening. So they're kind of like autonomously controlled, movement that doesn't interfere with the rest of the program. It's pretty neat. All right, so Socrates is moving around. I don't know what else to make it do now. Like, it needs to do something now.
Some sort of walls or something so they can't go off the screen? Or
Well, I think what I want to do, let me see what happens when I go off the screen. Does it literally just stay off the screen? Oh yeah, it doesn't come. Right now it doesn't return. So I think what we'll have to do. Oh no, it does. It pops back on the other side of the screen. So what I wanted to do is change when you get to the edge of a screen. I got to figure out where the cutoff is, but I want it to move to do two things. I want it to move to the other side of the screen, which it seems like it's already doing, thankfully, and I want it to change the position on the map so we can redraw a different screen.
yeah.
So when you move off the screen, you're changing locations on a map. So what I envision is that when we go up, if we leave the screen, we pop back onto the screen on the bottom, but the map changes and we're in a different room of the map.
Yeah. Maybe you could start working on that, but just leave all the maps clear for now and have like a cross.
Yeah, and I could actually print on the screen. I could have something that prints on the screen what room we're in, so I can check to see if it's working.
Oh yeah, that's a good idea.
So what's weird though is because I need to figure out where the when to change it, because do I change it right when you hit the edge of the screen, or do I change it when you're completely off the screen? It's clear that what's happening, there's like an invisible border here that when you're in the invisible border you can't see the sprite at all. So what I'm thinking is that we need to maybe have a border. I'm not sure, because I like it to be kind of an outdoor world, but if you can't see where the border is, that may not be helpful. So we might have to literally have a border even though it's outside. And then when we, and maybe, but doors outside seem so weird, so I don't think that's right. I think I just need to figure out, probably when we get to the very top of the screen, when you can't see, but it's starting to just disappear because you're going off screen, there's an invisible border. Like right when you hit that invisible border, I think it just needs to go, if you go up one more, it just needs to go boom, move it to the other side of the screen, completely on the screen, and then change the room number or the room position. Let's see.
Yeah, that's what it feels. I mean, I can't see it, but yeah, I feel like as soon as you get off the screen, like if there's nothing stopping you from going off the screen, you can probably go off anywhere. And then once you've gone off screen, yeah, it just changes the screen to the new screen, and then you appear from the bottom.
Yes.
Or from whatever side you just walked to it too. But yeah, it gives the feeling like the room just transferred to that side as you walked off.
So let me list out my program. Part of what's hard is it's actually very similar to Pico 8. You just can't see very much of the program at once. So, and you can't even scroll like you can in Pico 8. So that's even worse than programming in Pico 8. You have to list out chunks of line numbers, like list out line 500 to 1,000 if you want to see part of your program.
Oh wow.
Yeah. Hey, it's old. This is circa 1981.
Very cool.
Programming like it's 45 years ago. Okay, so let's get another. So we check for player movement, and then I think our next subroutine needs to be, let's just do it at line 110. Go sub. Let's just do this at 1,050. 10,050, excuse me. Okay. So 10,050 remark. Okay, so right after we check for movement, we need to check to see if we've changed rooms. So map screen change. Okay, what's weird is it's checking the position of the sprite is based on the top left corner of the sprite. So Actually, I might need to get the position of the sprite. I think there's a way to get the position. I think it's called position if memory serves. Position. Returns the position of a specified sprite in given dot row and dot column as numbers from 1 to 256. Okay. Yeah, so before we do the if then statement, we need to get the value. So call position. Dot row, dot column. Okay. Sprite number 1. I guess it doesn't really matter what variable I use, but Socrates X, comma Socrates Y. Basically, you're just defining these variables in the middle of this call position statement. Okay, 10,070. If Socrates X, no, let's do Y first. If Socrates Y is, so we wanted to change the second we go off the screen, right? So if it's less than 1, then, okay, so do we want, I guess we'll just do it, even though it's kind of weird, we'll just do it. If we go upwards on the map, we're increasing the map value by 1, the Y value by 1. If we're going right on the map, we're increasing the X value by 1. I think that makes sense, right? It's different to how the screen is mapped, but that's okay. I think it just makes, it'll be easier for us to understand where things are on the map if we do it that way. Okay, the map X equals map X minus, no, plus 1. Yes, okay. Okay, if Socrates Y is less than 1, then map X equals map X plus 1. That looks right, I think. 1080. If Socrates Y, yep, is greater than, let's see, what is it? I gotta find the max value here. Gotta go back to the sprite subroutine. Sorry, I'm looking at the manual while I'm doing this. You know, it's been a long time since I've done this, so. What is the dot value? Okay, yeah, dot column, dot, yeah, dot row can be from 1 to 192. So not 192. We'll do it we'll do it that way first, but I think I need to lower that because it's counting from the top left of the screen. But let's just call it 192. So if Socrates Y is greater than 192, then map. Oh, actually, I actually put map X. Then map Y equals map Y minus 1. So I need to fix the, there we go, Y. Okay, let's stop the program. Okay, now I need to do the X values. If Socrates X is less than 1, then map x equals map x minus 1, because we're going to the left. Oops. And 10,100 if Socrates x is greater than, what was it? It was 256. Then map x equals map x plus 1. Oh, equals, no typo. Okay, and for now, I just want to print on the screen what row we're on. So, or what screen we're on. So, just as a little debugging code here. 10,110 display at, I gotta remember that, how to do this. There's a way of just printing text anywhere on the screen. Gotta find the right syntax for it here. Okay, yeah, display at row column. Let's just call this 10, 10 for now. Let's do map x what's the best thing to do? I forget the separators here. Semicolon map y. I don't know if it works that way or not. Okay, then we'll return. Okay, so right now I'm going to show you what I've got here so far, Dylan. I've got two little numbers being printed on the screen, and those are the map x and the map y coordinates.
Cool.
Now I'm hoping that if this works correctly, when I leave the screen. Oh, nope, something's not working right. Something's screwed up already. Yeah, okay, I don't know what's happened there. Oh, it's running away on its own. Oh my god, what's happening? Okay. Nope, something's wrong. What did I do wrong? Okay, hold on. I'm not sure where I went wrong here. Let me see what exactly it's doing. Okay, so far it's doing fine. Oh, weird. Oh, I think I know. Okay, hold on. That's so weird because okay, if Socrates y is less than 1, then increase the y value by 1. But that's the one that was changing, so why would you do that? Socrates y is greater than 192. Yep, okay. Y, not Y. I'm already confused why it's not working right. Let me check some of the other directions, see if I can figure out why it's acting weird. Okay, now that's not working right at all, so I'm just checking all the directions here, seeing why it's acting weird. It's acting weird when I go one direction. And I see why, because it doesn't. What happens is if you say you're going to the right and it's counting pixel by pixel, so if I'm going right, it might be I'm at pixel number 10, pixel number 11, pixel number 12. When you get to pixel number, say 190, you know, if it's 250 some odd pixels to the right, if you get to pixel number 257, it'll pop you back to the other side of the screen, but it won't change the number back to 1. It'll keep you at pixel number 257. So when you leave the screen, we actually have to reset the position of the sprite to be at pixel number 1 again manually.
Cool. That's cool. Okay, I just got the ace. I'm gonna run in here. And
yeah, do what you gotta do. I'm just kind of like trying to figure out why this isn't working as expected already, you know.
Perfect. I'm just gonna leave my phone on speaker in the car. I should be back pretty quick.
Okay.
I'm gonna also go ahead and order myself some food. I'm thinking. I'm not sure yet. I might though.
I'll be right here.
Cool. I'll be back soon though.
Okay, Odd, you're saying send you a private email address. You can send me a good basic book. Okay, awesome. Let me message you real quick. Whisper. How do I do that? Okay, I'm trying to figure out how to do that. How do I whisper you? Okay, I click whisper, but it doesn't do anything, so that's weird. Actually, you know what? I don't really care if people see this. Here you go. This is just my email address. It's fine. There you go. I don't think people are beating down the door to message things to my email address, so it's all good. Okay, but why isn't this working? Okay, so I think if oops. So basically we need to say if Socrates y is less than 1, then we're going to change the map. Oops. I can use booleans, right? I can say and do something else. I hope. Awesome, I'll do that. But do you know off the top of your head, Odd? So what I want to do is I want to say, you know, if Socrates y is less than 1, then change the map value, and I want to do something else. Can I just do a boolean? Can I just say and like this, or is it something else in extended basic? I think you can do that too. Not in TI basic, but in extended basic, I think you can do that. And I'm going to try it. And how do I change the position of the sprite? If I just want it to pop somewhere else, do I have to say call sprite all over again? Probably, huh? Let's go look at the sprite program here. Because I don't think you use the call motion statement to do that. Motion. Yeah, that just literally changes the velocity, which I don't want to do. I want to I think I have to recall this and call sprite. Number 1. 96. I think you just have to recall the sprite. Um, 15. So it would be Socrates X, comma, and we're going to change it back to 1. So yeah, so what this is saying is if Socrates y is less than 1, so if we're on the left edge of the screen, oh, I'm sorry, the top of the screen, then we're going to increase the map y value by 1 to change the screen, and then we're going to draw. No, it'll have to be at not number 1, but it'll be at what's the max y value here? 190 something or other. Sprite. 192. Okay, so if Socrates y is less than 1, in other words, we're at the top of the screen, then increase the map y value by 1 since we're going upward, and that's what we decided on. And then call sprite again. That'll take sprite number 1 and move it down to wherever the x value is going to stay the same and to position 192. Let's run that and see if it works. Okay, so if we go upward to the top of the screen, okay, that did not work. Why? Why? What am I doing wrong? It is x comma y, right? It's not y comma x. Oh, wait. It might be row. Oh, yeah, it is row and column. It's not x and y, it's row and column. Ah, bloody hell. Okay, now I see why it's not working, Dylan. It's row and column, not x and y.
Cool.
It's y and x.
Oh, sorry. Somebody was going the wrong way and one way for a second there. I was like, no, don't do that, but they did not.
So I need to rewrite line. Yep. So this is Socrates y and Socrates x. That's why it was behaving weird originally before.
Nice.
Hey, look at us. This program's coming right along already.
Yes, sir. Yeah, we're already further than we were planning on getting today.
Okay, so now I think let's just see. Okay, so no. Well, it's kind of working. But it's in this weird in-between state where it's not... Okay, I think I see what's happening here. What's 192 minus 8? 184. Let's try it now. Okay, that's still not right. Something's wrong. Um, 10,080? What's wrong with 10,080? I think what I want to do is also report out the, let's see, row, column. So let's see, 10, comma, 12, Socrates, X, Socrates, Y. I can see exactly what's happening this way now. Run. Oop, that's weird. What did I do? Oh, I see what I did. Okay, hold on. So I'm just adding a little debugging code here. 12, comma 10. Okay, so the top two numbers are the map numbers, and the bottom numbers are Socrates' position. So here we go. So in theory now, when I go to the top of the screen, this is working pretty well actually. In theory, when I go to the top of the screen, the Y value should reset. Why is it? What did I do wrong here? Oh, it's going to be something totally obvious, right? Oh, it's the row column thing again, right? it's messing me up big time. I think. Okay. Yeah, so row. Yeah, so this will need to be right 184, which is because it's calculating based on the top left of the sprite, right? So Socrates X. Okay, so now when I go off the screen, it should pop right back on, except it doesn't. And that's weird. While I'm off the screen, it's like there's this weird buffer space. Is there something? I guess part of the map is invisible, so I need to learn where the boundary actually is here.
That'll probably help.
Because it's weird. It's like I need to. It's like some of the values are not actually on the screen. Let's run it again. Figure out what's happening here. Because if you look, what's happening here, so far so good. The Y value is going down as expected. And then we get to the edge of the screen, and all of a sudden, it starts rapidly changing the map value. Why would it do that? Yeah, it's almost like, because like where does this boundary happen? Like we start to disappear. Right there. Okay, so we go up even a little bit. It thinks we're at 250 something, but we're not visible on the screen yet. So when do we become visible again? Try to get this down to the pixel here if I can. This is fun, but it's frustrating because it doesn't. Parts of it don't work like you expect it to.
Yeah. Learning curves.
Okay, 192. Okay. That's weird because if it's at, why does it jump like that? Why does it jump from 193 all the way to 229? That makes no sense. Yeah. It's just not totally clear where the boundaries are. Because what I'm trying to do is if I go up like this, the moment we get to the edge here, which should be at y equals 1, if I can get it there, it's actually kind of touchy. It's not responsive like you want it to be, you know. So right there, you know, the moment we go up, we should go to the next screen, but that's not what's happening. So why not? I should just use row and column instead of X and Y. It's really fucking me up. Okay, well, let's see. So call position. Get the Y, get the X. If the Y is less than 1, I might just have to do this in terms of row and column. It's driving me nuts. I think I am going to do that. Just do a little surgery on this here. Socrates Y, that'll be Socrates row, comma Socrates column, row and column. Socrates row is less than 1, then map Y equals map Y plus 1, and call sprite number 1, 96, 15, I think it was 184, Socrates row, column Socrates column should be exactly as it was. If Socrates row is greater than 192, then map Y equals map Y minus 1. I'll add the rest of it. I just got to figure out why it's not working. It's just so weird. If Socrates column is less than 1, then map X equals map X minus 1. If Socrates column is greater than 256, then map X equals map X plus 1. Sorry, Dylan, this is really boring.
Yeah, that's how the first little bit is always going to go.
Mm-hmm.
I'll learn how to use a new system.
Okay, so at least we got this part working right. So when we're heading right, the row is increasing. Header left, the row is decreasing. Column, excuse me. And then row decreasing, row increasing. So that's working. We just need to figure out where the boundary is here and why. Like the moment we hit 1 here, we need to go. It's just not changing like it should. It's going to 256. Why would it do that? It should go immediately to 190 something. Did I use 256 instead of 192 somewhere? Because we should, the relevant line here is 10,070. If Socrates row is less than 1, then change the map number and call sprite number 1, 96, 15, row 184, and the column should be exactly like it was. So that's right. But that's not what's happening. Because it's supposed to calculate it from the top of the screen, right? There must be some like buffer space or something before it. I don't want it to be partially visible. The moment you leave the top or hit the top and add, you know, go up by 1, I want it to instantly go to the bottom of the screen. Since it is a cube, maybe you have to add 8. Let's try it. So on line 10,070, you're saying if Socrates row is less than 9, perhaps? Does that cause you to automatically? Oh, syntax error. No, I didn't like that. What did I do wrong? If Socrates row is less than 9, change the map by 1 and call sprite number 1. Okay. Syntax error. Won't see a syntax error. Okay, I'm totally confused about that. If Socrates row is less than 9, then map y equals map y plus 1, and then take the sprite and move it down to row 184. I mean, I guess let's just try something different. 170. Let's just see if maybe it doesn't like that number for whatever reason. Part of the fun of programming, huh, Dylan?
Mm-hmm.
Like, what is wrong? Why isn't it working?
Yes. Troubleshooting. Yeah, learning the new environment. Like, yeah, where is that boundary at? Especially since it's off screen.
Yeah, it's weird. It's like there's an invisible boundary around the screen that is It's like it's so the edge of the screen is not where you think it should be, and that's very strange. So
Yeah,
okay.
it's got to be defined somewhere. I'm sure somebody's defined, but not in the manual.
So in line 10,
where it's actually at.
oh yeah, we'll figure it out. So on line 10,060, we're getting the position of the sprite, the row and the column, in terms of dot row, dot column. And then on line 10,070, if the row, which is the y value, is less than 9, then change the map value, map y equals map y plus 1, and then call sprite number 1, 96, 15. That's the row, 170, and then Socrates' column should stay exactly the same. Let's change this back to 1. We didn't have a problem there. Let's see if this... It's when I changed it to 9 that it started having issues. See, now look, now there's no issue, but it takes a minute for it to... I think it, you know, honestly, I think what's happening, I think it's because it's a sprite, like it's moving. What I truly don't understand is why it's getting this value of 246. Unless, because look at this, this number right here is the y value. It seems to be changing correctly, but then when I go off the screen, look what happens. It goes all the way to 255. There's only 192 dot values on the y-axis, so why would it go to 255? I need to look at the manual and on the sprites here. Like what is happening? Okay, here we go. Dot row and dot column are numbered consecutively, starting with 1 in the upper left-hand corner of the screen. Dot row can be from 1 to 92, and dot column can be from 1 to 256. Actually, dot row can go up to 256, but the positions from 193 to 256 are off the bottom of the screen. The position of the sprite is the upper left. Okay. Okay, so it can go up to 256. But those are off the screen. 193 to 256 are off the screen. Okay, that's so weird. So it's not actually 190. It is 192. So that means that when I see what's happening, I think it's because we're might have to not do this using sprites. Maybe there's a better way to do this. I think what's happening is that we're going off the screen, and then the sprite is moving autonomously while other stuff is happening. And then it automatically goes down to 256 while other code is still running, and then eventually, and then it's not less than 1 anymore, and that's why we're getting this runaway map thing. Okay, I think I see what's happening. I'm not sure if there's anything to do about it. I think the key is probably to not use call motion, because that's causing the sprite to move in a way that we don't want it to move. So yes, that's what we're going to do. We're going to change line 1020. That's causing the problem, because when we move off the screen, it's moving autonomously before it ever checks its position, and that's why we're getting a runaway map value. Sorry, Dylan, you're not seeing what I'm talking about, but I think I'm seeing the problem a bit.
Cool.
So we need to rewrite this. Call sprite. No. Call position. Number 1, Socrates, Y, no, we said Socrates, row, comma, Socrates, column. Okay. Well, it's funny how even though I haven't done this in a while, I do have some familiarity with this system and its quirks. It's a quirky system in a lot of ways. Okay, so call sprite. Socrates column. Minus joist Y, comma, Socrates, row, plus joist X. That should move the sprite. Oop, that's more than I meant to list. Okay. Run. Bad value. Why?
Okay, I've made it back home. So if we want, you can tell us to do Discord again.
Yeah, let's do it. Yeah, do it. Well, that way you can see what I'm doing.
Exactly. Yeah, let's try to switch over to Discord again. I had to decide and look it on my computer.
All right, let's hang up. I'll see you in Discord.
Cool. See you in Discord.
Okay, bye.
Bye.
Okay, bad value. Why did I get a bad value? Oh, I see. Forgot the it's call sprite number 1, comma 96, comma 15, comma now all the rest. Socrates column minus joist y, comma Socrates row plus joist x. Okay, that's, oh no. Wow, that's even, it's working, but barely. Okay, it's not working right. I'm stuck in a loop. I don't know what's happening, but it's not working right at all. That's not working. Yeah, exactly. I fixed one thing and put a bug in something else, right? Oh, there's a typo. Okay, that's so weird. It's not moving as expected at all. So something's wrong. Oh, I see. Because it's doing it by factor of 4.
There we go. Okay, can you hear me now?
Yes, I can.
Hey, and I can hear you and see everything.
Nice. Okay, so I'm trying to...
Oh, wow.
Yeah.
I love it.
I think this needs to be divided by 4. Comma Socrates row plus joist x divided by 4. I think. Okay, it's so weird that it's getting stuck in a weird little loop. I do not know what's happening here or why it's happening. It was working okay, and then it gets all screwed up. Funny, this is all new to you. This is, you know, this is how I used to program when I was a kid, you know?
That's so cool. Yeah, this is brand new to me as of today.
Mm.
Which I've definitely heard of this system.
Have you?
Mm-hmm. Yes.
In what
But I've never
context?
just people talking about it. Probably because I like old video games. So
Yeah,
I
yeah.
like old games and older systems, and I'm interested in that stuff. So I'd heard of it, but I'd never used it or seen it or played any games on it or had access to it or anything. I've never really tried either.
Well, the cartridges were programmed in assembly language, so they run much, much faster than programs in BASIC.
Cool.
Okay. So, player movement. Call joist. Okay, that detects looking for stuff from the joystick. Joystick number 1, joist X and joist Y. Okay. Then we get the position of the sprite. Socrates row, Socrates column. Once we've done that, we can say, we can redraw the sprite because the joystick is returning these weird values of in increments of 4. 0, 4, 4, 4, so on and so forth. Super annoying. So we take this, we redraw the sprite. Number 1 is the sprite number, 96 is the character code, 15 is the color. So Socrates column. Column is... Oh, wait, I see what's going on. Okay, yeah, I screwed this up. I get it. Okay, this is my fault. Row minus joist y. Column plus joist x. Aha! There we go. It's slow, but we're moving. I don't think we want it to go that slow, do we?
Probably not. Probably a little bit faster than that.
Okay, but at least we got it. We got that working. And now we should actually let me run this because I think what should happen now. I know it's going to go slow, but let's try to get it off the screen. This should hopefully solve the problem with the sprite continuing to run while we're in the process of calculating its new position. And it should, wherever the boundary is, it might not be right, but it should change the map number correctly now, I believe. So the two numbers on the top here, the 0 and 0, Dylan, this is the map position, map X, map Y. This is the row number, or the sprite X and the sprite Y value. Oh, and we get a bad value. Y. Why are we getting a bad value when we run off the screen? Because the y divided by 4, because the joystick value returns values in increments of 4. If you look at the call joist routine, it's returning values for those variables of either 0, 4, or negative 4. For some reason, I don't fully understand. I think maybe because so you can control the speed of something. It's not returning 0 and 1, it's returning 0 and 4. So I divided it by 4 just to be able to increment the increment or decrement the position of the sprite, the dot value of the sprite, based on one pixel at a time, as opposed to 4 pixels at a time. And if I didn't do that, which we could do real quick right now, let's I'll show you what it'll just move a little faster. That's how we'd move it a little faster. So we can just say, comma, Socrates column plus joist x, skip the divided by 4, and now it'll move a little faster, I believe. Yeah, see, it's moving a little faster. Increments of 4. So it just allowed me to move things 1 pixel at a time as opposed to 4 pixels at a time. But 4 pixels is actually better. Might even do it by 8. But why were we getting a bad value? Do you want me to walk you through the code so far, Dylan, so you can see what's going on here?
In just a few minutes. I'm trying to get this new cartridge.
Oh yeah. Take your time. Why on earth would we be getting a bad value when we go off the screen? I'm really confused because, you know, on line 10,020 at the top of the screen there, we're getting the position of the sprite, the row and the column value for its current position. Then based on whether the joystick is pressed or was just pressed, we take that row, and it was fine when it goes into the negative numbers before.
Oh. Oh. Oh no. I just dropped a piece in the wall that I needed.
Uh-oh.
I don't know if I can fix it, so I might have to go back to Ace right now.
Yeah, do what you gotta do. It's okay. Do a trace. Oh, good idea. Trace. Run.
Oh no. I'm so stressed out suddenly. It's a little clip, like the little retaining clip, and it wasn't like all the videos I watched online. This piece that where I had to take the clip out was outside of the wall, but in my house it's like inside the wall. I was trying to push the little retaining clip in, and it like popped out and just fell inside of the wall.
Uh-oh.
Yeah, I don't even know if I can make it back to Ace before they close. What time?
My love.
Yes, my love.
The alarm just went off on the bread.
Oh, it's done?
Yeah.
Oh, well, we should take it out then.
Okay.
Hey, Odd and Dylan, I'll be right back. I got some bread in the bread machine. I need to take the bread out of the bread machine. So hang tight. I'll be right back. Oh, that was fast.
It smells so good. That's it? Is that okay? Okay. Right here. Yeah, you need tongs to do.
night, they're closed.
It turned out okay.
I think so.
I love you too. I'll be back. See you in just a little bit.
Yeah.
Right. I love you. Okay, I am back. Hello. Okay, so it is spitting out a bad number in line 10,022. As soon as you're at the top, the number is making a problem. Right, exactly. But why? I don't see anything that would cause that to happen. I think maybe we're trying to redraw the sprite before we define. Well, we are defining the new position here, right? We're saying. No, I guess I get what's going on here. We're trying to plug in a negative value for the. Yeah. Okay, I see what's happening. I think. Okay. Let me think. So, we need to say probably yeah, basically we just need to say, rather than redrawing the sprite, we need to say calculates the new position of Socrates. We need it's the old, X old and X new and Y old, Y new trick, right? We need to say, we need to calculate the new position. If that position is less than 1, we need to tell it go to the other end of the screen, which we're trying to do down here. I kind of want to start this part over because now that I've tried it, I think I see a better way to do it. Yep, that's what I'm going to do. I got a new idea. Okay, new idea. I know it's tedious to redo stuff, but that's what programming is like, right? Oops. I might have missed a number there. Let's just... Yeah. Okay. Starting over on that. I think what I want to do okay, 100 go sub 10,000 for now. 10,000. Remark player movement. Okay. call joist. 1, comma, let's see, I always got to check the manual here. It's joist X and Y. It's so weird. It's X, you know, some of the other coordinates are row and column, but this is column and row because it's X and Y. It's so annoying. So joist X, comma, joist Y. I like that part. It helps me understand what's happening there. Okay.
I'm back now. I don't know if you knew I was gone.
Oh, I gathered you were gone, but you're back on Discord? Yeah.
Yes, I'm on Discord. I can hear you again.
All right.
I am.
Did you have to run to the hardware store again?
They are closed.
Oh, okay.
So like they.
Well,
I'm going to try to put together without the retaining clip, and yeah, hopefully that works. Yeah, the roommates need some water tonight, so I'm hoping I can get this to at least kind of work. No, I feel like it's not going to though, actually.
okay, so I think I figured out. I'm zeroing in on how to do this. I erased everything, and I'm trying it again a slightly different way. Okay, so we detect, look for a joystick press. Might add call key at some point. Call position. That gets the position of the sprite. Now we want to do a little math before we attempt to redraw anything, because that was part of the problem. So what we need to do is if, let's see here. Socrates column, no, row, less than, oh, minus, actually, let's do if Socrates row minus joist Y is less than 1, then Socrates row equals, we said it was 192 minus 8, which is 184, I think is the right way to approach this. Okay, so if Socrates row minus the joist Y is less than 1, then we want the row to go to 184. That'll be the other side of the screen, the bottom of the screen. If Socrates row minus joist Y is greater than 184, then Socrates row equals 1. Plus or minus. We'll tweak the numbers here in a little bit. If Socrates column plus joist X is less than 1, then Socrates column equals, then I'll move it over to the right side of the screen, so 256 minus 8 is 248, I believe. If Socrates column plus joist X is greater than, I think 248, same thing, then Socrates column equals 1. Okay, so that'll give us new values for Socrates row and Socrates column, and now we can redraw the sprite. And actually we can change the map while we're at it, of course, too. So I might edit those to change the map number. Let's just see if we can get it moving around correctly, and then we can worry about editing these to change the map number. So 10 or 100 or 10,070 call sprite number 1, comma 96, comma 15. You watching, Dylan? Oh, you're busy. That's okay.
Yeah. Try and put this handle back on.
Let's see how oh, we didn't put the go-to statement back in there. And we need, let's untrace list. Let's get the go-to statement. We need the return statement. Get out of this subroutine. And let's just do, I don't know, 32,000. Go to 100. Return without go sub list. Thought I did a go sub. What? Return without go sub. I do have a go sub. It's on line 100. Why does it say as a return without a go sub? Yeah, that's weird, isn't it? Because we have.
Let my roommate turn the water on real quick.
Yeah, that's okay.
I'm gonna take with me. If you turn the water on.
On line 100, we have go sub to 10,000. We go to line 10,000. We do all the things. Then we hit to line 10,080. I have an idea. Take 100 off. I mean, for now I can just do a, yeah, for now I can just do a go-to statement. Go to 100, right? Or a go to, whatever is 10,000. Good enough for now. Okay, that's not working. Not working. What did I do wrong? Oh, I didn't actually move anything. Okay. Oh yeah, I need some. It needs to be if then else. Yeah. I see the problem. Okay. This needs to be else. Else. Call sprite. Number 1.
I'll be right back. Sorry, Nate. I'll show you in a minute. Okay, sorry.
That's okay.
I had to drop that piece in the wall. So funny. Can't believe I drove all the way down
Socrates
there.
row. Yeah, what do you do? Joist
Right.
Y.
Pivot, make a new plan.
Socrates column. Okay. Yeah, I'll explain this here in a minute. Just in the middle, making these little changes here. Else call sprite. Oh no, I don't want to do that. Okay, hold on. Sorry. Drat. Okay. Yeah. Okay. I see here. Because I already have a call sprite statement below. So this else statement, I just need to redo the math. No fast way to do this. There's no highlighting. See how tedious it was to write a program back in the day, huh?
Yeah, right. That's what it's making me think of. How cool it is that this team figured that out and was able to do this.
There's always a tendency to think that people in the past were stupider than we are, you know?
Yeah, I try not to fall for that pitfall.
Programming has definitely changed, though, for sure. Okay, so now we need to do, though, okay, if Socrates row is less than 1, then we set it to a certain value. Otherwise, we just do the math. Socrates row equals Socrates row minus joist y. Basically an if-then-else statement. And we do the same thing over here. Okay. Else. Yeah, I'm probably going to switch to doing this in a more modern code editor. But, I'm kind of enjoying showing Dylan what it was like to program back in the day. Well, when we get a little further into this, we'll probably copy all of this into a more modern code editor. But of course, if we do this on the real system, we can't do that. So once we our ultimate plan is to make a game and actually start selling them on cassette, old school style, rather than just to see if that works. So we'll have to do it on a real system at some point. But for now, we're just getting started, so it's okay. Oh, wait a minute here. Okay, we need... oh, man, I'm having such a hard time thinking through this logic.
Hey, water is back on and there's no crazy leak. I'm just going to go let my roommates know and then I can focus on this meeting for the time.
That's okay.
Okay. Cool. Thank you.
I think it's still the same, yeah. It's positive for the x because of the way that it's the difference between the positive and negatives on the joystick value versus the positive and negatives on the y-axis on the screen. So it's a little funky. It doesn't look like it's right, but it seems to be right. Else Socrates column equals Socrates column plus joist x. Oops. Oh, did I just delete it? Oh, shit. Okay. That's the downside of this. If Socrates column plus joist x is greater than 248, then Socrates column equals 1, else Socrates column equals Socrates column plus joist x. Hey, so far so good. Check it out. Hey, all right. I can live with that. That's pretty good. I can live with it. Better. Let's save that right now. But I wonder why it didn't like the subroutine bit. Let's list it out again. We had line. So we had line 100 go sub 10,000.
Okay, I'm here. I'm locked in now.
Oh, here, let me show you what we got. I think I fixed the problem that I was having, at least part of it.
Nice.
Oops. Here, there's Socrates. We go up. We go left. We go right.
Wow.
We go down. We can go diagonal, whatever.
Cool.
And then boom, check it out.
Oh wow, yeah. Okay, so the border is actually before you go off.
Right, that's what's part of what's weird. Hey, Mela, look at this.
Oh, yeah.
Here we go. It's not much to look at, but
Socrates.
Socrates is moving around the screen.
Oh, very Socrates.
Right at.
Okay. I love it. Okay, good start. Small, and you can create it to what you need it to be.
Exactly.
I love it, my love.
I mean, it's it's just a dot moving around the screen,
It's
but
very elementary, but
it is very elementary. Yes.
there's so much to
But
expand on.
it took
And at least you have the movement down.
It took 2 hours to get this working correctly, so
And
it's
that's
pretty good, huh?
That's great.
You know, it's funny. The more I look at it, it's just because my eyes are that dot looks pink.
Oh,
It's
Yeah,
actually gray. Interestingly enough.
no, it looks pink to me.
I know.
I love
Yeah,
it.
mom, my dot is moving exactly. Yeah, right. I think we want to change the color. I don't think I like it being pink. I want it to be gray. Just didn't look right. Do you want me to run you through with the code so far?
Yes.
Okay, so let's list. Let's just list line 10 to 100 first. Oop. Okay, so line 10 clears the screen. Line 20 defines two variables, map x and map y, each of which is 0. That should be pretty clear, right?
Yes.
Line 30 is the hexadecimal character code for Socrates. So each character is a little 8x8 grid, and these hexadecimal values 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, and F define which dots in that grid are turned on, and you can actually see how that works if you look at. I'm going to pull up the manual here. You can see the manual on my screen, right?
Yes.
So right here, basically, here's your 8x8 grid. Each row is divided into 2 blocks of 4. Boom, 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 boom. And this little chart here tells you what hexadecimal value corresponds to what. So if we want all the dots turned on, that's F, 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 F.
Okay, I see.
So if you want to define a character, you basically pull out your graph paper, plug in some blocks, and then literally one block of 4 at a time, left, right, left, right, left, right, left, right, to look at this chart and figure out what hexadecimal value that corresponds to. And then you make a 16-digit hexadecimal string out of that, and then give that a name, and then you use that name to define your character. So we're calling this string Socrates string, Socrates $sign. That's how this system for string variables have to have this $sign at the end of them. And then we're defining a character. What's that?
Oh, I said, how'd you do the color?
Oh, the color is right here, number 15, which is actually gray, but ends up looking pink when it's contrasted with the blue. That's interesting. So, we can mess with the background colors and the foreground colors and everything, but, so on line 50, we could change this to be white instead of gray, which would be 16. And then let me just list out the rest of the code. There's one more call sprite statement here. I just need to change that. So on line 10,070, this would need to be changed to 16 as well. So now it'll be white. Which I like a little better, actually.
How do you know what colors there are? Like what colors?
I literally have them memorized from when I was like 7 years old.
Cool.
They're in the manual.
Okay, cool.
I mean, I can find it right here. There's got to be where it's called color here. Color. Here you go. So 1 is transparent, 2 is black, 3 is medium green, 4 is light green, 5 is dark blue, 6 is light blue, 7 dark red, 8 cyan, 9 medium red, 10 light red, 11 dark yellow, 12 light yellow, 13 dark green, 14 magenta, 15 white, 16 gray.
Cool.
Yep. And so the characters are in groups. And so these character codes correspond to the standard ASCII character codes for letters. So like the only one I know, for example, off the top of my head is character code number 42, which is an asterisk. So each character has a number, a character code, and they're in character sets. So each set number here corresponds to a group of characters. It's so you can control the color of those characters separately. So when I define a character like I do here, I didn't mean to list the whole program. We'll list part of it here in just a moment. When I define a character like I do here on line 40, this means call character, call CHAR. I'm saying character number 96, whatever that is, rewrite it to be whatever I've defined this string to be. So character number 96, which is probably some character. Oh, and you can put several sprites on top of each other to make a more complicated picture, for sure. So if you want to make something a little more complicated, then, so different parts of it can have different colors, you can definitely do that. It affects performance because you're only running one line at a time. But in any case, so I'm defining a character number 96, saying it's going to be this string, which is basically a solid block, and then line 50 actually draws that to the screen. Call sprite. Sprite number 1, character number 96, which I just defined, color 16, and then the position on the screen in terms of its dot value. X, row and column. It's not X and Y, it's row and column. It's actually Y, comma, X. Very annoying.
Okay. Yeah, backwards.
Yep, so now let's list the rest of it. Is that all going to fit? Nope, not quite. Okay, So right here, this is how we're starting to control the player movement. This is just a remark, just a comment. Line 10,010, call joist. That is looking for input from the joystick, which on the emulator maps to the arrow keys. So joystick number 1, because there are 2 joysticks on the system. The X and the Y value in terms of whether those are on or off. So you can go 4 directions and then diagonal directions. So it reports the X and the Y on the joystick differently, gives them variables. And then what I'm doing is so it's looking for a joystick input, then it's getting the value, the position of the sprites. All this line 10,020 is doing is getting the positions of the sprites and giving them the name Socrates row and Socrates column. And then we're going to do some math. If the row minus the joystick Y is less than 1, then we bump it to the other side of the screen. We set the row to be 184. Otherwise, we just do the math and subtract the joystick value from the row. Line 1040, same thing but in reverse. If the row minus the joystick value is greater than 184, then move it to the other side of the screen, set the row to 1, otherwise just do the math and give Socrates row a new value. Let me list out the rest of the program here so far. And same thing with the X's. So here on the, starting with line 10,050, if Socrates column, which is the X value plus the joystick value, is less than 1, because the joystick value can be plus or positive or negative, then set the column to 248, in other words, move it to the other side of the screen. Otherwise, just do the math and give it a new position on the screen. 10,060, same thing in reverse, other side of the screen, and then finally we're just redrawing the sprite. Once we have the new values for Socrates row and Socrates column, we just have to redraw that sprite. Sprite number 1, character number 96, color 16, which is white, the row and the column, and then we literally just loop back to 10,000 where we begin looking. And so this is just, so lines 10,000 to 10,080 are just running in an infinite loop right now.
Okay, cool.
But for some reason we're getting an error when we try to put it in a subroutine. I don't know why, so I'll have to look into that. But yeah. But now we're not running off the screen partially. If we ever get a fractional value or a negative value, we just boom bump to the other side of the screen and redraw the sprite.
Cool. So
Cool,
you're
huh?
actually moving. Or are you staying in the same map location?
Right now we're just in the same screen because the way I was doing it was causing problems, and now it should be a simple matter of here we can do this right now. It'll be very easy actually. Let's see what line I need to start with here. We need to start with line 10,030. I think we need to add an and. Oh, I wish there was a way to insert. There's not a good way to insert here, is there? Oh, there is. You can actually insert. Cool. One of those rare cases where the insert key actually does something. Okay. So what we need to do now, whenever we bump to the other side of the screen, we need to change the map value. So right here, before the else, we need to say and change the map value.
Cool.
So let's get insert on. And let's see, we're talking about the row, and we're talking about if it's less than 1, so we're at the top of the screen. So we want the map y equals map y plus 1. Otherwise, stay on the same screen and do what we just did. Oh shit! It deleted line 10,040. Okay.
Oh, what?
Yeah. That's right. I'll just retype it. If Socrates, it's already on the screen, so.
Perfect.
Yeah, it's much more finicky than than Pico 8. If Socrates row,
Well, I like it so far.
you like what?
I like the feel of it so far.
Yeah, I do too.
It's cool. Yeah, it feels solid. In a weird way. I don't know how to describe what I mean, but
I think that fixed it. Okay. Still have insert on, I think. Nope. Okay, if Socrates, okay, column. If it is less than 1, so if we're on the left side of the screen, so we need to say and map x equals map x minus 1. Interesting, it turns off insert. Interesting. Okay, and map x equals map x plus 1. Okay, I just want to make sure everything still works. Okay. Why am I getting an error now? What did I fuck up? Okay, if Socrates row minus joist y, I'm here at line 1030, then Socrates row equals 184, and map y equals map y plus 1, else Socrates row equals Socrates row minus joist y. That looks fine, I think. If Socrates row minus joist y is greater than 184, then Socrates row equals 1. And map y equals map y minus 1, else Socrates row equals Socrates row minus joist y. Okay, 1050. If Socrates column plus joist x is less than 1, then Socrates column equals 248, and map x equals map x minus 1, else Socrates column equals Socrates column plus 3. Okay, that looks pretty good.
did you already define what the different maps are?
I did, yeah.
Okay.
Oops. Okay, Socrates column plus joist x greater than 248. But Socrates column equals 1. And map x equals map x plus 1. Else Socrates column equals Socrates column plus joist x. That looks fine. So why are we getting an error all of a sudden?
Can you go off any of the sides? Do any of them work?
I don't think so. I think he didn't like the way I added in the...
That must be something doesn't like about that. Seems it's getting confused about where to maybe move the sprite to, since it's calling 10,070 out. And that's where it's drawing the sprite, isn't it?
Yeah.
Actually square, so maybe it's just getting confused on where to move it to somehow. Yeah, this is fun. So new world.
I want to look at the format and if-then-else statement in extended basic, because I think maybe I messed up the if-then-else statement here. Very old manual here.
I love it.
Okay, so yeah, after the then you can have multiple statements. So it's not, I don't think we need an and. I think we need to do these double dots. Let's try that. So rather than and here, I'm trying to check the example. Okay, yeah, so we can have these. One thing, so there on the system, the version of BASIC that comes built into the system is called TI Basic, and the if-then statements work a little differently in a regular old TI Basic. You can only have, you can't, when you do an if-then statement, you say if this, then you put a line number, it goes to a different line number. And this is called TI Extended Basic. This version of BASIC, it's a cartridge that plugs into the original system, usually a more advanced version of BASIC, which is built into the emulator here. And it lets you do things like having more than one, more complicated if-then statements, is what we're doing here. But I think what we need to do is this.
Oh.
Oop. Insert. And then I think we need it doesn't like, okay, there we go. Let's try that. Syntax error.
2030. Okay, new error. That basically replaces an and, or was like an and before and?
It's more like having two statements on the same line.
Oh, okay.
But why is there a syntax error now? If Socrates row minus joist y is less than 1, then Socrates row equals 184. And it kind of mirrors exactly what we're seeing here, right? If blah blah blah, then blah blah blah, a colon to give you another statement, or else blah 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 blah. Why are we getting a syntax error? Because we have if something, then something. Another statement that follows after that. Then we get our else statement. Then we have...
So small and blurry on my screen and so
Oh, yeah.
Yeah, I can't really see the colons on my computer as well.
Syntax error. Odd, are you still watching? Do you see any syntax error on this line? What am I doing wrong here? Our viewer, Odd One Man, is familiar with the system. He's tuned in several times and I've been doing TI stuff.
That's so cool.
Maybe he doesn't like the spaces? Oop. I don't think that has anything to do with it. I really don't. But
Hard to tell from here. Yeah, I can't see the colons. They look like an R or an equal sign or something.
It does look right to me as well, but I'm getting a syntax error nonetheless. Maybe it just doesn't like the spaces, which is... Nope. Yeah, see, it adds them right back in anyway. I mean, we could, you know, do funky stuff like adding a subroutine, like say then I don't know, yeah, go to the change map subroutine, but I just don't see any errors. If Socrates row minus joist y, change 184 to 100 to test. Okay, sure. I don't think that's the problem. It all started when we added in this this section here. I mean, let's just delete this. Now it works fine. Oops. Get back to that one line. So I want to do two things at once. I want to be able to say, if the row minus the joist y is less than 1, then change the Socrates row, which is right here. And I want to do something else before the else. I want to say, and change the map value. So I thought you did that with the 2 colons and then another statement and then a couple more colons after that, which is what the book seems to imply. Right here we have if something, then a statement, colons, another statement, then we have 2 colons, an else, and a couple of statements after the else. But it looks like you can have more than one statement following the then. Which it says as much here. It says statement 1 and statement 2 may each be several statements long, separated by the statement separator symbols, which is the 2 colons. They are only executed if the clause immediately before them is executed. Right. So I don't see why we're getting an error when we try to do that. And we can try it again right now. Let's just see. Map x equals map, actually y, right? Map y equals map y plus 1. Statement separators. Right, so if Socrates row minus joist y is less than 1, then Socrates row equals 184, statement separators, and also do map y equals map y plus 1, statement separators, or else, and we're off with the else clause. But now it doesn't like it, even though it looks syntactically exactly like what's in the book. I don't think the statement is too long. We haven't reached the line length limit, but it sure doesn't like it, does it? There's a section on Boolean operators here and how to use Boolean operators. Let's see here. If I can search in here. Boolean. No matches. Relational expressions. Here we go. Oh, nope, those are like numerical relation expressions. Okay. Logical expressions. Here we go. Okay, so yep, and. Alright, so let's try and again. Okay, if Socrates row minus joist y is less than 1, then Socrates row equals 184 and map y equals map y plus 1. Let's try it. Doesn't like that bad value. Why is it giving us a bad value now? I know it says 1070, but this is... Out of curiosity here. I don't think it works this way either. Let's try it though. I see nothing that would keep that from running the way it was though. Yeah, it doesn't like that. I don't think it works that way.
Back to being a syntax error though. It went back to being a syntax error instead of the other, whatever that other one was.
Yeah, I don't think it's the joist y that's the problem. Because that's just giving you a value of plus or 0, positive 4, or negative 4, depending on which direction the last joystick detection was. So I don't think that's the problem. Because now, when I take out that other clause, now it's going to work fine. See, boom, now it works fine. It just doesn't change the map value.
Yeah.
So I don't think that's the problem. And the joist y, of course, comes from the call joist statement. That's just the name I gave the y value from the call joist statement.
Could we write it without including it in there? Like, just have it be its own if then statement? Like, if you hit the 184, then change the map?
Yeah, I definitely could. I mean, I could have it do a subroutine. I could have it. I mean, I could do an old school TI basic style without, just have it send to a separate line number and, send it to a subroutine and then, send it back after it's done it. I hate jumping around so much like that. Too many letters on values? Oh, you think it's the, I mean, what do you mean too many letters on values? Like Socrates row? I mean, it's working. I mean, it's working though. So, right, it's only not working when I add in. Oh, sometimes it overflows. What specifically overflows? Is a memory overflow error of some sort? I mean, I could change it to. Okay, I mean. I mean, it doesn't have to say Socrates. I can just change it to SOC or something. Let's look at the manual here. See if there's a variables consist of 1 to 15 characters. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that's probably not the problem. I don't think that's, I mean, it could be, right? But I don't think that's the problem. I mean, I could change everything from Socrates to just SOC. Yeah, sure. I mean, old programmers, conserve every little bit of memory they can conserve, right? So, longer variable names take up more memory.
Mm-hmm.
Lines may be up to 140 characters long, including the line number. So let's just list 1030. Let's 140 characters, including the line number. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. Even at 28 times 4, we're nowhere near the line length limit. Shorten it just to try? Sure. I mean, I have to do it in the whole program, right? So let's just do this. So we're gonna get rid of everything that says Socrates is now gonna be SOC. That's fine. I'm all for saving memory. So sock row, sock column. Sock row, sock row, sock row, sock row. Sock row. Gives you a new appreciation of how old games were made, huh?
Mhm.
So, there we go, lost one there. Okay. Okay, let's list it out, make sure all the changes took here. Looks pretty good so far, doesn't it?
Mhm.
Run. Okay. Now let's look at line 1030, which is causing all our problem. So insert map y equals map y. We're talking about if we're going north, so +1 colon colon. Watch it work now. Nope, doesn't like that. I just don't understand because it's exactly the same as what's happening in the book. Under if then else here. Take away else. Well, that's not going to work because, I mean, if you look at the, yeah, but we only want this value to change. So it's an if then else statement. So if this condition is met, then we want to do these things. Otherwise, we want to do these things. We can't just get rid of the else. Because if you're going off the screen, we want to go to the other side of the screen. Otherwise, we just want to do the math and move the players. We can't just get rid of the else. Oh, you mean get rid of the double, the double colon before the else? Sure, we can try that. Like so. Sure. That doesn't look like what the book looks different than that. But now it works. Okay. But if you, it's weird, but because if you look at the example in the book here, like right here, I'm going to blow it up so we can see it. We do get this weird. We do get the double colon right before the else.
Yeah, it's so interesting.
Okay, so let's do all the other statements like that, because at least it's not breaking anything, and then we can check to see if we're actually iterating the map value correctly, and then we can probably call it in there. Okay, so let's do the other one, 1040. So this needs to be 2 colons, and then no else, right?
Yeah.
This needs to be 2 colons. And that looks right.
Mm-hmm.
Good times, huh?
Cool.
Okay, so that should, let's just check make sure it's working, and then we'll check to see if it's iterating changing the map values properly. All right, so far so good. That's working. So now what we need to do, I want to add just something that reports on the map value. Okay, so let's do it right here, just under. Oop, 10. Let's do it. 1075. Display at 10, 10. Let's do map X, map Y. I think that'll work. Okay, so we're at the starting screen, 0, 0. Oh, check it out, look.
Nice. Oh, cool.
We're changing screens, check it out. So this should change the other one to 1. Then we go back down, boom.
I like that. That's so cool.
Look at us, we're moving around the map now.
That's so cool that it has the numbers like that. It just keeps counting. So how far can you go? Like,
Well, right now there's no limit.
Literally?
Well, I mean, well, not literally. I mean, you know, until you run out of memory, there's some maximum number, you know, but
Cool.
some enormous maximum number. Yeah, so we just have to add some other conditions. You know, if you're, you know, we probably need to put boundaries somehow. We'll need borders. We'll need something to indicate what the boundaries of the whole overall map are. You know, we don't know yet. So it's more stuff to add in. But for now,
You can explore.
yeah, I mean, check it out.
Cool.
Yeah, program size limits, exactly. So we're gonna encounter the program size limit before we encounter any other limits. Pretty cool, huh?
It is. Can we put the numbers in a different location, or?
Oh yeah, I can put them anywhere right now. I just threw them on the screen randomly just to be able to check our work here. You know.
Yeah, I love it. That's so cool. Yeah, I feel like we could keep something like that. And be able to tell where you're at easier. Maybe a little mini map or something.
Yeah, in fact, probably, you know, we probably just have coordinates, you know, map coordinates, and then the name of the room you're in. You know, we're in, you know, in front of the courthouse, or, you know, courthouse for the Youth of Fro dialogue, or, you know, whatever the host of the party's house is for the symposium dialogue. You have to have a Socrates walking animation. I don't know. I kind of like just this weird abstract idea that you're just this square Socrates talking to other little square characters. I think the more abstract and weird, the better, personally. But I know I'm in the minority, but it's like, it's almost... I used to love Adventure on the Atari 2600, where you're literally just a square. I love Gertrude's Secrets, where you're just a square walking around. I like the idea of this as just super abstract. And also, you know, it's totally Platonic, right? Plato's all about abstraction to general principles. So strip away the non-essentials and just get right to the philosophical heart of this. It's in keeping with the Platonic theme, I think. So I'm inclined not to have any little walking animations and just to make it super, super, super duper abstract.
I was imagining that's it. So just a square, maybe with a little trail that moves behind it, like a little ghost trail.
Yeah, I think that's possible easily, because if we use 2 or 3 sprites, if we count on the non-playing characters not moving, which I don't know why they would. If the non-playing characters are moving, they don't have to be sprites. They can just be characters drawn to the screen, just like these are characters drawn to the screen, but they're not sprites. Like the number 3 there is just a character. So we can redefine other characters and draw our static artwork not using sprites. The only thing that need to be sprites are things that move.
Yeah, I wasn't really imagining anything else moving.
Yeah, and so I can't wait to see what you come up with for the art, because, you know, I don't know, we need to come up with a list of locations and then see what we can do to make the art. And
You find some maps and send me maps and lists of like places you want me to
yeah, I will. I think probably what we need to do is start test the new extended basic book later, easy to drop. Yeah. I think we just need to like whittle it down a little bit. Like, okay, let's get a map of ancient Athens. Let's compare it with the most important of Plato's dialogues, and come up with some arbitrary location of the rooms or the scenes on the map based on those locations, and then we can just start drawing those. You know, start with like, you know, suppose you go this way and you go into a, I don't even know how it would work. Like you go into a house, like, you know, boom, or maybe you actually, you know what I think it is. I think it's probably something like, I don't know. It might not be. We might like, say we're in the main area here, and it's like, okay, we're going to Plato's symposium now, which is at someone's house. So, you know, maybe there's an entryway to. There's a house with an entryway up here that you can go in if you're on this map. You know, who knows? We'll figure it out.
Mm-hmm.
But some of it might just be like, you know, like there might be, if this screen right here is where the courthouse is, it could just be like, over here there's like a courthouse building with like a little path that goes away, and you can go onto the path, and maybe in front of the courthouse there's you know, Euthyphro standing in front of the courthouse, and when you get close to Euthyphro it begins the dialogue, you know. So that's kind of what I envision. Like you're walking around, and maybe somewhere like up here there's 1 or 2 or 3 more little squares, and they're standing around, and something to indicate there's a conversation going on, like maybe a little, you know, a couple little exclamation marks above them, kind of like quests or something. And you know, when you get close to them, you know, a certain proximity, you know, maybe within two squares of them, your movement gets locked, and you're stuck in dialogue mode now, where some dialogue happens, and you get to engage with these characters. And then when your dialogue is done, you can start moving again, then move on to other parts of the map.
Yeah.
Something to that effect.
Yep.
Before I forget, I'm going to save my work here.
Good idea.
Socrates, I'm calling it Socrates work in progress. So it's funny because this is actually pretending to save it on the virtual disk. Like this is what I would do on the real system. I'd save to DS2, which is, you know, disk number 2, and then I'd give it the file name to go on that disk. And now it's saved it to a virtual disk in the emulator here. But it functions exactly like the original system does. Yeah, map of the town. We need a map of ancient Athens, exactly.
Mm-hmm.
And we could even have a mini map maybe that shows where everything is, just like in modern games. You know, we could do a little hyper abstract mini map, kind of like you know, Legend of Zelda style.
Yeah, I would love that.
Mm-hmm.
Yeah, I need a map. Try to
In the design document, I think I do have a map of ancient Athens.
Oh, cool.
Which is not that helpful because we don't know what from Plato's dialogues corresponds to what on the map yet. So this map might be way too big, and a lot of this stuff may not need to be on our map for our purposes. So I think the key is to take the locations from Plato's dialogues, look at this map, and see do they obviously correspond, or if not, like the Pyrrhian gate here, that might be part of it, or one of these gates. I don't know which gates are which. But this may not show all the locations, so we might just have to take some creative liberties, you know.
Mm-hmm.
I'm pretty stoked I got this working, actually.
It's working well. Haunters.
I didn't anticipate this would be as easy as it was. I mean, it only took like 3 hours, but I like that you can go diagonally too.
Yeah, I wasn't thinking we'd be able to go diagonal.
So I think your challenge for the artwork is to let me get rid of this and that. Let me go to the CHAR programs subroutine here. Yeah, so here you go. So let me show you here, just to get, I know you're a little more visual, so let me show you, where is it? Okay, so here's our screen. we've got 32 characters by 24 characters. This is the whole screen. Each of those characters is an 8 by 8 grid like this.
Okay. Okay.
Which can be turned on or off. And they can be layered with sprites, but if we're not using sprites for the static stuff, they can't be layered. So, and each character can only have a foreground and a background color. So that sort of fine-grained color, you know, 3 different color pixels in the same 8 by 8 grid, it doesn't really work that way. So think monochrome graphics, more or less. You know, we can change the color, but monochrome. You know, foreground and a background color for each character. So, you know, I would say liberally get out a piece of paper and start sketching graphics. Once we know what we're going to draw, like, okay, we know we're going to need a courthouse. Okay, let's build a courthouse building, an ancient Athenian courthouse. Who knows what the hell that looks like? We don't have to Google it, right? Socrates is, you know, the symposium dinner party. So what does it look like when you're at a dinner party? Well, we need a table with characters sitting around a table. So some sort of highly abstract table with a little populated by the different people talking at the symposium. You know, Plato's Republic. You know, I forget where that takes place, but they're out in public somewhere, you know, on the streets at a crossroads in front of the building, in front of whatever. You know, and so I guess what I picture is that, like, Socrates would be, you know, a neutral character, kind of like white like this. I like white because it kind of connotes some sort of platonic purity here, and all the interlocutors would be different colors. Like Euthyphro would be a little green square, and Alcibiades would be a little yellow square or whatever, and so just all the other characters would be the different color squares, and Socrates is the very monochrome, you know, white character talking to all of them.
Cool.
But all the
I was just thinking.
Yeah, so I think our next task is probably to start populating this world, because we can say, you know, when we're on a certain, you know, when we change the screen, part of changing the screen is drawing the proper background for that screen. So what we need to do is, you know, as soon as we change the screen, we need to clear the screen, draw the new background, redraw the sprite, and then we're going to move the sprite around to our heart's content. But every time we change the screen, we need to redraw the background. So we'll have a subroutine to draw the background.
Cool. How do we make walls?
Well,
and buildings that
I don't
pass through.
Oh, well, that's a really good question, because as of right now, you can just go meander anywhere.
But we would want to have, like, some spots that are kind of impassable. It's like you don't want to be able to walk through the walls of buildings. We want to, like, have to walk to the door.
I think that's right. I think what we need to do is probably, right now, when we're moving left or right, we need to check, is there something in the adjacent position? And if so, you know, kind of like we did when we were doing Frieza's Fury, you know, if there's something immediately adjacent to it, then don't move it. And if there isn't, then move, you know.
Yeah.
But we're actually kind of doing this, right now we're doing this in groups of 4 pixels. So we just need to, yeah, I'm not sure.
Can you do, like, a grid system?
Well, right now we're in a grid. We're actually moving by half. If you notice, we're moving by half grids.
Oh, cool.
Or actually, are we moving one whole square at a time?
Move one more? Oh, maybe, actually, yeah.
I think we are. Yeah.
Oh, go.
Yeah, we're moving one whole square at a time right now.
Okay.
Interestingly enough, I don't know how exactly we're doing that. I didn't think it was going to...
24, right?
Yep, so we just need to, because right now you just move over things, because there's no, this 0 isn't an object, it's just drawn to the screen. So sprites are objects. You can say, check to see if there's an object there, but if we're not using sprites for the graphics, because you can only have 4 sprites horizontally in the same row, then we're going to have to come up with some other system. So I don't know yet is the long and the short of it.
I think that could be a fun place to start, is try to, like, be on the home screen, I guess, 0, 0,
Mm-hmm.
and, like, maybe play or Socrates in a little box. It's like his home, and it's just in a box. He's on like a little bed or something, could be,
Mm-hmm.
or at a desk, like thinking. And then you start the game inside of his house, and then you walk out from his house, and we could start there trying to build just walls around the square, and that you have to go out the door. You can't go out anywhere else.
Right. So kind of like it's just an open box with a doorway with something to imply that it's a house.
Yep, 3 walls, and then 4 walls, but one of the walls has a door on it. So you have to navigate to that door and go out through the door, and everywhere else is a wall, and you can't walk through.
Yeah, it's interesting because I don't know how to do that, frankly.
Yeah, I think that could be a good place to start. That way we can start building out the map, and we know where to put all the different characters.
Yeah.
Start being inside of some random box that doesn't have anything in it. The only mission is to like realize that's how you move in this world. Is you can't go through these walls, but you can go out these if there's an opening.
This might be a good question for ChatGPT. Like, how do I add collision detection between objects, that aren't made up of sprites?
Yeah. How do we make it so you can't move? Yeah, because that'll be.
Because either it's
This game for this sprite to like really interact with would be walls, and then other sprites, which would just be a box somewhere that you can go start a dialogue with.
I think probably, yeah. I don't know, because let me think. Because sprites, you can have a finite number of sprites, and they can only have 4 of them horizontally on the same row, essentially. That doesn't give you much in the way of graphics possibilities with sprites. But with sprites are great because you can actually do the math between the sprites. You can say, if the distance between these sprites is X, Y, Z, then don't move, or do move. 28 sprites and 4 in a row, Odd says in the chat. But if you don't use sprites for the graphics, if you use just regular characters drawn to the screen, then there's no information about those. They're just stuff drawn to the screen. They don't have any metadata like where this character is. Actually, now that I think about it, okay, I'm thinking through the options right now. There's I'll find it right here. There is a routine called GCHAR. It will read a character from anywhere on the screen. So you could say, check the nearest, if you're going left, check the adjacent slot in the screen, character slot. And if it's anything but a blank, don't move there.
Yeah, I think that would work because you'd never really want to go over anything.
Yeah, because even if we just draw, because basically what we're going to do is take those character numbers, which correspond to stuff on the keyboard and letters and numbers and symbols. We're going to redraw those, reassign those with new hexadecimal codes to create new graphics. Then we'll draw those to the screen. So say I have a little triangle drawn right here at this little square that I'm pointing to. If our player sprite is right here, I can say find the nearest adjacent. If I'm saying go left, check the adjacent. I'm not sure how to program this. It's going to be really tedious, but all we got to do is get it right once, right? So check the adjacent slot. If it's blank, allow the movement. If there's any character drawn there, don't move there.
Yeah.
So you can't be on top of anything else. In other words,
Yeah, you can't go through anything. Everything's solid.
I think that'll work.
You gotta go. Yeah, I can't think of anything you would want to be able to walk over.
Well, it'll be some complicated math because the reason is that this sprite is being done not by character grid, but it's being done by pixel grid. So the character grid is 32 by 24, but the pixel grid is, we decided it was whatever 1 to 1 256 and then 1 to 192, whatever limits we put on it. So we'll have to do a little clever math and say if we're at a weird pixel spot here, say 237, do whatever math it takes to find out which, divide it by 8 and do whatever to figure out the corresponding slot immediately to the left, even if it's a fractional, either here or the next full one over, and then do or don't allow the movement. So it'll take some creativity, I think, to write that in code, given the limitations of extended basic. But now that I'm talking through it, I think I can do it.
Yeah, I can even make the art to where it's like all of it's on the inside or the outside or something for the walls.
Yeah,
if it would make it easier.
Yeah,
Centered, or make the walls also be the same thickness as the whole space could also be possible.
I think that's wise. I think we want everything to kind of fit neatly into the grid. So, but again, each one of these characters, you can do whatever you want. So this character is 8 by 8, and we just happen to have filled it all in. But for every character slot on the screen here, you've got 8 pixels by 8 pixels to work with. You can turn each dot on or off 8 by 8 within this little square for all your other graphics.
Mm-hmm.
But try to reuse stuff, because if you can find a basic palette, I think the smart thing to do is probably come up with a series of characters you can define and reuse. So yeah, it's so important to limit the graphics, Odd says in the chat. Maybe make one square block, then make different shaped triangles, one like this and one like this. Maybe make one with a rounded shape here, rounded shape here, rounded shape here, rounded shape here, and then use those as basic building blocks to build your graphics. Come up with a palette of Legos that you can reuse, in other words.
Okay, yeah, I was thinking mostly square stuff.
Yeah, but I think, but it could be triangles, it could be little circles, it could be, go nuts, but I would say come up with, 20 or 30 different basic building block shapes, triangles, squares, rounded edges, that you can then assemble on the screen any way you want, because that's really easy. Once we have those characters done, I can put them anywhere you want, no problem. It's just that we're going to run out of characters if you go too fine grained with if everything is a beautiful and unique 8 by 8 design, we're going to run out of characters to use.
Cool. Okay. Yeah, I was mostly thinking squares, like that one game you showed me where the lady was sitting in the rocking chair at first.
Oh yeah, exactly.
Yeah, hard borders, very abstract, like you were saying. Pretty much wall. I was imagining most things being pretty much rounded, and then maybe during the dialogue having some more intricate art maybe in the background. And it kind of goes to a new screen, and now you're in a dialogue screen, and there's maybe 2 characters kind of standing there, not moving or anything. It's just standing there, and the words change underneath them, and maybe the pictures change every couple.
Yeah,
of seconds.
Let me think here. One. Let me think.
And then after the dialogue, you go back to being the square.
So this is too chunky. This is not detailed enough. What the fuck is going on here, right? In this old ET game.
There, yeah.
Even when there's buildings on the screen, it's just this. Okay, it needs to be better than this. This is ET's version of ancient Greece. Look at these columns and stuff. It's just that's ass, right? We can do better than that, right?
Yeah, let's see. Yeah, I need to see more of how detailed you're thinking then.
I guess more than this. I mean, I would if these are columns, they should have little lines like columns do, they should.
At least I was well, yeah, if it's 8 by 8, then I could every other one leave the background color or leave transparent or something.
Right, exactly.
More of a column happening there. Yeah, in the house, I think I would rather have a door than just windows.
This is just too abstract. I like abstract, and that's too abstract. What's the other one? Raiders of the Lost Ark 2600. I know we're talking Atari now instead of. Here's a good kind of. This is interesting. So, look at this. So right here we got a little baskets and a little flute, and this is a little guy with a parachute. It's all monochrome and chunky, but it's not just these giant chunks, What else? I'm trying to think what other game I could show you as inspiration. Let me think. Here's that adventure game where you're just a square. So this is some of my aesthetic inspiration here. Big and chunky, but you know, look at the door. It's got some detail. It's a pattern. You know, it's a grid, but it's a pattern grid.
Okay.
So you don't feel like everything has to be solid blocks, but think repeatable patterns. You know, like the doorway to this castle here. Oop. I can get a picture of it now. Yeah, so here's a castle, very abstract, but okay, here's a door, and it's a pattern, but it's a grid, but it's one little character that together forms a pattern. So I could see the same, like if there's columns on the building, I could see this stripe, you know, a little character with some stripes in it to connote the, you know, the stripes on the columns, you know. You don't seem convinced.
Oh no, I'm just kidding. And
Yeah.
Curry.
You also what? Sorry.
Eating curry.
Oh, that sounds good.
Yeah, it's pretty yummy.
So you know, you can kind of see. You know, I want something abstract but still detailed enough where you can tell what it is and make good use of the system too.
I'm thinking mostly blocky, but on like some aspects have more
Yeah,
details.
I agree.
So it's like blocky, but there'll be like some tinier details that make it feel less.
I guess what I envision is if you had something like, okay, if here's our, oh, it's 7:00. I should go in a minute. But let's say here's our 8x8 grid. So one character you might have is just a solid block, just like we've got, as a building block, something you can build graphics out of. And then one character might be a triangle where, you know, diagonally these blocks and everything in between down here is turned on, but a diagonal triangle. Then same thing the other direction, all 4 directions of that. So 4 more characters. And then you might have a little curve like this, you know, boom, 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 boom. And then everything down here, so it's more like a rounded edge, 4 of those, 4 rounded edges. And then you might have a sphere. And then you might have a diamond or whatever, you know, just come up with a palette of building blocks from which you can arrange, you know, like Legos into building all kinds of interesting things. And maybe you have stripes or maybe you have a grid or maybe you have whatever, you know, and those are your and then treat that as your building block palette.
Okay. Yeah, I think it'll be easier for me when I know like what to draw with them.
Yeah, definitely.
Shapes to make for them, and I might make them just like, okay, I'm gonna make a column now, and then make a little palette for how to make a column, and do it like, okay, I need walls, I need a corner for a wall, make a whole room. Now I need something to indicate a door.
Yep.
It'd be fun if there would be a door that. No, I think the door should just be like an open hole, maybe.
Yeah, I guess I had in mind that most of this is going to be outdoors because I think really most of Plato's dialogues take place outdoors, you know, where it's just Socrates talking to a group of people out in front of a building, with a couple of exceptions like the symposium.
Yeah, I haven't watched or like studied anything about the dialogue, so I'm not familiar at all. So
yeah, let's see here. Let's see, Euthyphro dialogue. Euthyphro. Let's see. Is there a setting here?
Indoors and outdoors.
Yeah, here we go. In this dialogue, Euthyphro meets Socrates outside the court of King Archon, okay, where Socrates is currently waiting to defend himself against the charges, blah, 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 blah. Euthyphro, okay, so yeah, but that one takes place outdoors. So you just need, you know, whatever this court of King Archon looks like. I have no idea what the hell that looks like. Well, who's King Archon here? Oh, it's means King Magistrate. Okay, but what would that building have looked like? I have no idea. But that's just outdoors. So for something like that, it could just be like a mock-up of a building that he doesn't need to go into, and then he's talking to Euthyphro outside the building. You know, boom, easy. But then, you know, one of them might be like the the apology dialogue, that takes place in a courtroom, essentially. His jury? In fact, this might be fun actually, because Socrates had a jury of his trial had a jury of, I think, 501 people. It's not like our modern jury of like 12 people. There was a much more democratic than our republic is. So Socrates' trial takes place in front of a jury of, I think, 501. And so it would be interesting to have some mock-up of a giant, almost like a little amphitheater with, a bunch of little squares populated, and to indicate the jury, and Socrates is, giving his little spiel in front of in front of this large group of people. That would be in front of a large group of other squares. That would be really interesting.
That would be.
Yeah. So that one takes place indoors. The symposium.
I guess when I'm thinking of making the map, I'm thinking of having like one space where you can kind of like an open world is what I'm thinking, not like a linear game. I'm thinking it's kind of.
Oh yeah, likewise.
Until you find the spot. So I'm trying to think of there would be basically all a map would be is where are the different buildings at.
Right.
So I guess that's what I'm thinking of, like how to make the different buildings look different. They all need to fit within this.
So the starting area, I think you're right. Let's just start at, Socrates' house or something. That's a cool idea. And then let's say you go this way, and then either on the next screen or 2 screens over or whatever, I don't know yet. Let's say, okay, now you're going to, this is where the symposium dialogue takes place. You're going to a dinner party, and you go in, as soon as you get on this screen, maybe either through a doorway or maybe just whenever you're on this screen, you're just, boom, you're magically inside such and such's house, and now you're at a dinner party with a table and a bunch of other little squares to talk to. And and then if you leave the dinner party, boom, 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 maybe you go up 2 screens this way or up 1 and to the right or whatever. Boom, now you're at the courthouse and you're talking to Euthyphro. Boom, 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 and you have a little conversation about whatever goes on in that dialogue for a while. And then you go up here a couple more screens, and boom, now you're in the courthouse on trial. And you go down, this screen, and 2 more over here, and you're talking with your friends, and you're in prison about to be executed. And maybe each screen will have its own little. Some things only make sense in progression, but I like the idea of the open world better. So maybe some of them you have to unlock, like you can only do Plato the Phaedo dialogue where you're about to be executed after you've done the trial, stuff like that.
Like the dialogues are in a linear time, but you can like go and talk to other ones, but if you haven't activated the first one yet, then like the 4th one can't start.
Yeah, I think that's right. I think some of them don't make sense unless you've done some of the others first, but a great many of them are just one-off conversations too, where there's the progression doesn't matter as much,
Those ones don't have to be locked then.
Right, exactly. We
can set, but have it be where you can free roam, but whenever you talk to the right person, it activates a dialogue scene, and then the remembers that.
Or if you try to go one way and you haven't, you can't go to the prison yet until you've done. So it's like, you haven't just have something that says you haven't unlocked this part of the map yet, or whatever,
Yeah. Okay.
Yeah.
Go talk to Yada first.
Yeah. Go exactly. You're trying to go to the. I don't know what it would say exactly, but like, this part of the map is unlocked. Go talk to Euthyphro first, or go to the courthouse first, whatever. Like, it doesn't make sense to have a conversation while you're in prison if you haven't even done the courthouse dialogue yet, right?
Do something from him too, like, oh, maybe I need to go talk to this person first.
Yeah, exactly. So also be thinking about, given how do we want to do the dialogue, it's not going to be as easy to do like little pop-up boxes like we did before. I think we probably just need to have an overlay, where the text just pops up along the bottom or something,
I was imagining like another screen basically during the dialogue scene, like another.
Oh.
I don't know if it another map or
I guess I would.
But yeah,
I guess I was envisioning like if you're talking to a couple of friends up here, you know, like say you got a couple other squares you're talking to up here, you know, the bottom half of the screen might just be, you know, white text on top of a colored background, you know, Socrates, blah blah blah, Euthyphro, and then choose your response kind of stuff.
I guess it depends on. I wasn't thinking for all of the conversations. I was just thinking for like the big ones mostly.
Mm-hmm.
The normal ones, like just more regular ones, yeah, just like some text maybe at the bottom. But then for like the bigger ones, I was thinking like just a picture of like Socrates talking to whoever he's talking to, and I just draw those up, and then the bottom is the text, just like every other time.
Sure, more like a little dialogue cutscene.
Yeah, like a little cutscene pops up.
Yeah.
I wasn't imagining movement. I was just imagining making one solid picture, like pixelated.
Yeah.
Socrates standing there talking to somebody, but it's like, yeah, they're more probably just their faces or something.
Odd wants to know if you ever done any TI stuff, and no, Dylan. This is Dylan's first time looking at TI stuff at all. So he's heard about it, he said, but has never experienced it. So it's funny because I think you'll immediately find that we're going to run up into the limitations of this even quicker than we ran into the limitations in Pico 8. We're not going to run into a code limit. I think you're going to run into a limit of like, how do we create the loops that send this program around, and how do we create the cool thing you just described, and given the graphics limitations, and it's limited in a different kind of way than Pico 8 is. So
I'm excited to see how it.
Yeah,
these are just coming into the thing. That's like how I was kind of imagining it, because I was imagining most of the art would be like super duper abstract, like just lines mostly is what I was thinking, and then those like cutscenes, it would be a little bit more artsy, and that's where I was thinking most of my creative endeavors would be those scenes, and maybe like the cover art for it, or if there's like a title screen for this.
Yeah, I think the nice thing of, I like that because it's one mechanic we can reuse. We can say, okay, go to a cutscene, and then it'll be which cutscene. If it's cutscene 1, then draw these characters. If it's cutscene 2, then draw these characters. But some of it is going to be difficult to do that way. Like a one-on-one conversation might make sense that way. But what about when Socrates is talking to in the apology dialogue, when he's giving his little speech in front of the jury of 500 people? Like, that's a lot to draw on a TI. Like, a lot to draw on a TI.
Maybe on that one, room just has like a bunch of little squares populating the audience, but then in the cutscene, if there's a little cutscene for that one, it's just like his face talking, and you can't really see the background. Like, it's
right, yeah, exactly.
Judge or whoever he's talking to, because I'm not familiar with any of it, but I'm gonna watch some videos. I need to be familiar with it.
I think it's funny, if you type in TI-99 4A programming videos, you'll probably find a lot of my videos because I've been making videos on these for a while. But
I need to Socrates story. That's what I need to.
Yeah, actually, okay. I'll find you a video right now, because there is a video.
Oh, sure.
There's just to give you a sense of what's possible. This is another guy that makes TI videos, but he knows a lot more about it than I do, and he's a lot more comprehensive than I am. I'm basically just doing fun stuff. This guy's actually trying to teach you some things. Okay, so we're using TI Extended Basic, and so this whole video, I'll put it in the design document.
Oh, perfect.
TI Extended Basic video. So it's not so much a tutorial, but you'll get a feel for what's possible from watching this video, I think. So let me add a link to it right now. Make sure that works. Yep. So this guy does. I just closed it. Come back. There we go. I think most importantly, he'll show a lot of screenshots in terms of what's possible. You'll see examples of graphics using this.
Cool.
And I'll give you a sense of the possible. Like, here's a screenshot. That's you can see there's not a lot of room to do other stuff. Here's your little 8x8 sprites, and here's your little you know, it's going to be fundamentally abstract. But here's a good screenshot. Check this one out. Whatever's going on there, wherever it is.
Even a
Boom. You know, really abstract.
Yeah.
But you can see the tendency to reuse. You know, this is the same basic pattern over and over again. These things are the same things in different colors. Think building blocks you can reuse.
Yeah, definitely.
Yep.
Cool. Yeah, I'm feeling more and more excited.
Yeah, me too.
Yeah, it's like, well, it like could get complex, but I think I've got it in my head. But I do think that drawing like the actual pictures of people is going to be complex. I'm a little bit nervous about it, but I've got the idea in my head well enough to where I'm feeling pretty confident.
Yeah, yeah.
Yeah, cool. Imagining walls kind of like those, basically.
Right.
But do you want them thinner than that, or do you feel like that's too thick if the character is that thick? Or do you think that's fine like that?
I don't know. I think let's start with that until we don't like it, you know.
Okay. Yeah, I was thinking that would look good right there. That's exactly what I was thinking for our room, actually. Just that most center red one you're on.
But I think if you combine a solid square blocks like this with little triangles and little rounded edges, you can get much more creative than this.
True. Yeah.
Not everything has to be just a block. You know, it can be a block and a block. It's like think building blocks when you're a kid. You know, you got blocks, but you also have little triangles, and you got little circles and little spheres and little cylinders, and you know, think like that.
Yeah.
You know, maybe little arches. You know, who knows? Whatever.
Yeah, I'll have to look at the art and like the architecture from that.
Yeah, I mean, ancient Athens architecture. I'm just curious, actually. Let's see what we get. I mean, obviously, it's all the temples that are still there, but, you know, I mean,
yeah,
a lot of temples and a lot of, you know, I mean, you know, even something like this, even though this is outdoors, you know, I mean, Plato had a jury of 500 people, a little indoor amphitheater shaped thing, a little picture some of the abstract version of this, a bunch of little squares around.
Rounded. You have more rounded stuff.
Yeah, it doesn't. You know, we're not obviously not going to see. There's a picture of the Acropolis. You know, so yeah, so that might be one area. The Acropolis might be an area you can go visit. Maybe you run into someone there. I'll go through Plato's Dialogues. I think as the next step, I'll put together a list of specific locations and anything obviously related to them, like. This is inside at a dinner party with 5 other people attending, and anything else we can find out about it. Or this is outside of a courthouse, or this is inside of a courthouse, or this is inside of a prison, and we need this happening. And just, you know, but pare it down, abstract, you know.
Mm-hmm.
I'm just pleased I got my little square walking around.
Same. Yep, now we need to figure out how to make walls. Make something that the square can't pass through. And get a map created.
Yeah, I think that'll actually be pretty easy. I think, you know, it'll be, you know, if I hit the right arrow key or move right with the joystick or whatever, it should be easy to say, okay, given the pixel value where I'm at, calculate that in terms of the grid values, either where you're at or immediately adjacent. Check to see if that's anything other than a blank, and if it is, don't move there. I think that's not going to be too hard. Knock on wood.
No.
All right. Well, I think we should probably call it a day. We streamed for almost 4 hours, and I got to have some dinner and stuff. And it's Valentine's Day, so I'm going to go spend a little time with Susan while it's still Valentine's Day.
Yes, go enjoy Valentine's.
Yeah, we already went out to lunch. We went out to a nice lunch at this dumpling place called Uncle Dumpling here in town. So it was delicious. Had some hot, spicy pork soup dumplings that were delicious.
That's so nice.
In any case, anyone who's tuning in, Odd included, and anyone else who happens to be dropping by, thanks for tuning in. If you're watching this after the fact on YouTube, be sure to check out the rest of my YouTube channel. You can find it under Cozy Azeroth or my real name, Zachary Fruhling. And follow our journey. You know, we've recently completed Frieza's Fury in Pico 8, and that's released on itch.io. Check it out there. And we're starting this game, and we're also starting another one called Fruits of the Forest that we're going to be building in Stencil. So keep tuning in on Twitch to watch our live stream video game development sessions, or check out our videos after the fact on YouTube. Most importantly, play our games. Go try Frieza's Fury if you haven't checked that out, and give us any good ideas you have for Socrates' Adventure, or whatever we're going to call this one. I don't know what we're going to call this one yet. And or Frieza's Fury, which is something like Booze Fury meets Stardew Valley.
Oh, that's Fruits of the Forest.
Yeah, that's what I mean. Fruits of the Forest. Yeah. Or this game. Two different games. Yeah.
Yes.
All right. Well, Dylan, we're off to the races.
Off to the races.
Good work today.
We meeting on Thursday, or do
let's plan on Thursday. Yeah.
Okay. Perfect.
That'll be great. And
Thursday.
And I'll give some more thought to some of the things we talked about, though, not walking through walls and stuff. So.
Cool. I'll let you know if I spend any time working on the games.
Yeah, likewise. I might try to make a little more headway on some of this stuff. Like, I'll see what else I can do between now and then if I have time.
Cool. Yeah, I'll try to get something downloaded for the Fruits of the Forest art, and at least watch a video or something about Socrates. What is dialogue?
Well, Plato wrote dialogues about Socrates, so Socrates is the titular character in Plato's dialogues. So I think if you just Google what are the most important Plato's dialogues, then go to the Wikipedia pages for each of those, you'll get a decent sense of what's going on.
Okay, perfect.
Yeah.
I'm gonna watch a bunch of YouTube videos about it, like several documentary type things.
Yeah, and I'll try to think of some way to make it more fun than just dialogue. Like, I want to have some reason for being in the game, so
I understand, the more I'll be able to help with that.
Yeah, likewise. I think I'm just having a hard time understanding like what the point is, other than just walking around talking to people, which is kind of what Socrates did anyway. So if it's that and nothing else, it's fine. But if there was
also fun.
If there were any sort of gamification elements whatsoever we can incorporate, that would be cool too. So I'll have to think about what that might be.
Yeah, like some sort of side quests.
Yeah, conversation points or something. Like did you score points here or piss someone off over here?
Yeah.
I don't know.
Yeah, I'll study it up.
Even reputation, because Socrates, he has reputation amongst his friends, but he really pisses off a lot of people in high positions, which didn't end well for him. So. Yeah, I figure we'll end the game on Socrates drinking the hemlock and fading out or something. Something really dark.
Yeah, it should be. Cool. I'm so excited to see where this one leads.
Me too.
I think it's a really...
Odd, thank you for tuning in. Yes, very cool session indeed. We actually got a little more done than I thought I would. It took a little longer, but we got more done than I thought we would. So good session. Dylan, have a good evening, and I'll look forward to starting on your game as well. So.
Yay. Same.
Have a good night, everybody.
You too.
Bye, everyone.